Yeah, hey Rumpus, can you hear me now?
Yeah, I can. I don't know what it is about my computer. It seems to be after a certain amount of time, my sound system stops working, and then it gets all clicky, and then I have to pull the the jack in and out, and then it sort of sorts itself out. But then, unfortunately, doing that, it seems to, then the Google Hangout things, I lose the sound on the Google Hangouts.
You on a laptop?
No. It's a proper full size desktop. But it,
full size desktop.
But if for some reason it's the sound, I don't know. After a period of more than a few hours working, the sound system obviously is very clever and does
Do you have too many tabs open?
I do have a lot of tabs open. Yes, that's true. But I'm surprised it affects my sound system. It seems to regularly go down. It's most annoying.
Yeah, I had a buddy that I was talking to one time, and on numerous occasions he had too many tabs open, and I don't know if it was too many tabs or compromised. One of the tabs were compromised, and it would screw up the sound system bad.
Right. Okay. Oh, that's interesting. Well, I do have quite a lot of tabs open. I think I've probably got about 150 open at the moment. So, so in about 5 windows. So yeah, that can.
Yeah, I'm thinking that might be your problem.
Right. Okay. Yeah, we've got to agree on a moderator if Pure doesn't turn up. Is there anybody? Let's have a look who's in the side chat who might be interested.
Yeah, I've never done this before, so I don't know how this works. So
well, we just have to pick a well, Fed is saying here that we should agree on. Oh, Gem Panda, yeah, he's fine, isn't he? He's very fair.
I don't know these people.
Yeah, Gem. I mean, he's not a flat earther, but he's a very reasonable. He's not a militant flat earther, if you want something like that. If you might. He's a very well-disposed character. I've never seen him. I don't think I've even seen him get angry or anything. Or really, he occasionally gets slightly annoyed, but fundamentally he's calmer than most. So it's all dependent on you, John. I don't know if you can see the group chat. He's Flat Earth is asking if you would accept him as a moderator.
Gem Panda.
Yeah.
I don't mind. Whatever you think is best, that's fine.
I'll put it like this: he's one of the least combative spherical earthers you can get.
Okay.
He's got a picture of a red panda. I don't know if you probably recognize him. He's
I think I had a couple interactions with him. I don't think he likes me all that much.
Yeah, well, you don't exactly ingratiate yourself with people, will you, do you? So I think that wouldn't. Unfortunately, that's not a criteria. I'm afraid you're going to be able to apply. I suspect.
I'm gonna try and curb that a little bit.
That would be very useful, yes, because I would say that was the most problematic thing about you.
Well, people take it the wrong way that I'm arrogant. No,
it's not it's not only being a bit arrogant. It's just the interruptiness that people in mid-sentence.
Well, everyone interrupts each other.
Yeah, you're about the worst person. I think I can't think of anybody who's worse than you.
Funny, I was thinking the same thing about you.
No, I think that would be unfair. If you go and review the debate we had before, you'll see that actually I often hold back. I let people. I tend Lex, for instance.
Yeah, well, this is all subjective anyway. But
go and review some of the meetings. Like, for instance, the one yesterday, where you were getting a lot of hack, when you were getting a lot of jip, and you compare my behaviour with Spurs and others who I didn't disagree with. I still let them finish what they were saying. Occasionally I'd interject. I don't object to the odd interjection. That's fine. There's nothing wrong with a snappy, occasional 2-second point. No, I don't agree with that or something. But it's when you actually stop someone in their tracks and stop them in their flow when they're trying to say something.
Yeah, well, some people get a little bit droning on and long-winded. So
that does happen. Agreed. But the trick is to say you're getting a bit drony and long-winded rather than persistently interrupt them. John, you can agree to Gem Panda?
Yeah, that's fine.
Okay. So, well, you should be on the case. I assume this is Gem Panda, the panda that I'm thinking of. I can't.
Is there some type of structure that we're going on here?
I must admit, I haven't prepared a structure. I was just going to go on the fact that whatever you say is wrong, and then I'll be able to tackle that. So there should be enough material.
Well, listen, I got 7 points that you made yesterday that I want to focus on.
Okay, well that's 7. That sounds like a long. That's easily. That should be enough material to get us going, I think.
I don't think we'll get done because we get bogged down. But you know, I'm not going to be pessimistic about it. Let me just go with the 7. A couple are real easy, so it shouldn't be any problem.
Yeah.
Maybe we were just miscommunicating too. That could be a definite player. So I haven't ruled that out.
Well, no, I fundamentally disagree with most of what you say, so I don't think it's a case of miscommunication. Okay. There's been a couple of occasions when there might be, but I'd say about 90% of what you said I've understood and disagreed with.
Okay.
So I don't think there should be. So. So where is? I presumed they had Gem Panda was kicking around in the chat or something, but he's clearly not. We seem to have some constructive comments in the side chat.
I'm not looking at the live feed.
Yeah, so it's not worth it at the moment.
No, I when I'm in Hangouts, I usually never do.
No, neither do I normally. But, given the, I was just assuming that seems to be just one sort of abusive character, just abusing Fed. But,
yeah, you get a lot of those. That's why I don't usually go in there.
It's not usually constructive, no.
No, I know it's not.
There's sometimes Negator's in there, and then he also says something intelligent.
Yeah, me and Nega had some run-ins. Of course, he's military, and I'm retired military, so we have some, common ground. Well, a little bit anyway.
Right. Yes. You do sound vaguely, military-like. Negator. Yeah, Negator's got a definitely a military sort of restrained, disciplined sort of air about him. I think you'd rely on him if you had to do something needed to be done. I'd definitely be happy to send in Negator to do it for me.
I don't know all these people that well. I just go by what they tell me.
Yeah, just the way he behaves. I'm just going. Yeah, I don't know anything about him other than what he says.
Right.
So I don't actually know. I don't know him at all well. But just the way he behaves, carries himself, gives me confidence.
I'm the newbie on the scene. So flat Earth has just been something that's come up within, I think, right around May 20th. So I'm pretty new to this.
Yes, you see, unfortunately, that's half your problem. Is you charge in, and you just scattergun arguments.
Well, I have a lot of information.
Yeah, but you see, I think you ought to try listening a bit more and talking a bit less. I think.
Well, I've been doing this for about 10 years with university professors, sir. So I have files upon files of information on various subjects.
The trouble is, you make many basic errors. I don't know what in your education.
I'm not making any errors. I support everything I say.
Well, for instance, you said that a train was a closed system, and
it is.
Oh my God. Okay, well that's one thing. Well, that's one thing we can go into.
Yeah, the only way you're getting out of it is the ventilation system. So let's close off the ventilation system and put people on there with oxygen masks.
Yeah, okay, well that's not but that's not the situation we were describing, was it?
Yeah, it wouldn't materially change your point.
No, no, it wouldn't. But the point was, you declared a train was a closed system.
It is.
No, it's not.
Only artificially. It's only artificial, sir. It's only artificially open because of the ventilation system.
Yeah, it doesn't matter what the reason is. I mean, this is why you see, I'm very confident. This is the sort of thing that you say that's so obviously wrong that.
Yeah, but it's not obviously wrong.
No,
it has no
you say it is a closed system. Or sorry, it isn't. But it would be if we did X, Y, Z.
Sir, no, it's just X, and it's just air molecules, sir. It has no material impact on your point whatsoever.
Well, sealing off vacuum sealing a train would be an enormously tricky task.
Just close the ventilation systems and
No,
put
it's
people
not.
on there with oxygen masks. You got a closed system.
No,
It's
no,
the
you'd have to
same concept.
You'd have to weld all the doors together. You wouldn't allow the articulation between the carriages.
We're quibbling. That's quibbling.
No, it's not.
Over
That's
nonsense.
No, it's not. This is the
it is because
your point. This is the lack of rigor you've got in your argument.
No, your point was
a closed system.
Sir,
is very definite.
Sir, your point was that people in a train won't feel acceleration, because somebody asked. I don't think it was you.
That's right.
I think
That's
somebody
correct.
else
yes.
brought the subject up.
That's right. I brought up the train.
I think it was.
But someone else was talking about how they could feel whether you were moving or not, or yes, there was someone else. And I always bring up the train example as a counter to that. But then you unnecessarily called it a closed system.
It isn't, sir. Geez, oh man, it's only air molecules.
That makes it a non-closed system. It's not as though you can't be half a closed. You can't be half a closed system. You are either a closed system or you're not.
Yeah, I understand that. So close off the ventilation system conceptually now. Close off the ventilation system because this is all concept anyway. Close off the ventilation system, and there goes your open system.
Yeah, I mean, I agree, but it doesn't affect the argument that the actual main issue.
Yes, it does affect the argument because now you have a problem.
Okay,
right?
Okay.
Well, I don't want to go.
Yeah, we're going past. We're going to this when we've got Jeremy in the.
Yeah, I was going to put this one down too, and I decided not to because we're not going to get anywhere with that one.
Well, it's very simple. This close. I mean,
I know. Okay, let's disagree to disagree.
I'm sure I could make a 13-year-old understand. I mean, the point was you decided to raise it as a closed system.
You don't even know what a hypothesis is. You can't even graduate 5th grade general science for crying out loud.
I'm afraid.
So don't give me your condescending sleight of hand backslides.
Well, I'm afraid you're
I'm going to show it too.
Right.
Yeah. Right off the bat. So let's get on with it.
Yeah. Well, we're having problems getting Gem Panda apparently, as well as. Well,
when he comes in, you call me.
As well as Pure.
So I don't waste my time because I was going to bring up some biochemistry to blow up your evolution fairy tale.
Okay.
Do you have a background in biochemistry, sir?
I know something about it. Yes.
So you're prepared for that?
Because
if you're, I don't think you are. So if you're not, I'm not going to bring it up.
No, you bring it up. No, you bring it up. No, you bring it up.
All right.
Definitely.
All right.
I don't think people. I think people here are watching this would want you to go full throttle on all your best shots at me, and I'm more than happy. Even in areas I'm not an expert, I'm more than happy to.
Yeah, but that's on what I was giving you a chance because if you don't have any history or background in biochemistry, it'd be like me teaching a 3-month-old trig, and I don't want to waste our time.
Well, okay. Well, you can. Okay. Well, once you've made me look ridiculous with your.
I'm not. That's what I don't want to do.
No, I want you to.
No, I don't, because it has no point.
Well, it does, because then you could establish some sort of credibility in this debate at the moment.
No, I'm not concerned about that.
Okay. Well, you might want to convince the people. I'm sure the audience would love you to demonstrate how much you know on the subject and how much therefore you can make a point, because it is it's a very important point. If you can demonstrate, if you have an argument to invalidate evolution, people are going to want to hear it, and I will invalidate your invalidation with my moderate knowledge of.
Oh, you're finished. You're finished. That's what I'm saying.
Right. Okay. Well, I'm sure that's people will love to hear that.
Sure.
So yes, you should. That's a subject matter, obviously, that not directly with flat Earth days, but people who believe in such things as flat Earth also tend to have a misunderstanding of evolution and chemistry, physics. Well, you've demonstrated on numerous occasions your lack of understanding of chemistry, physics, and biology.
Right. My evaluations are friggin' pristine. I don't think my bosses thought what you thought, brother. Get ready for the whirlwind.
All right. I see.
Yeah, because I'm tired of your backslide, sir.
My backslide.
You don't even know me.
Well, I know you're not terribly bright, I'm afraid.
Yeah, right. Right. We're going to see that here in a few minutes, brother.
Yep. Yep. Oh, dear. Where's this paper, chap? Where's paper or bloody, honestly?
From a friggin' guy that thinks friggin' ink, paper, and glue molecules can author technical instruction manuals. You're calling me not bright.
Sorry, what can offer instruction manuals?
Say again?
So, you said something about...
Yeah, it's tantamount to ink, paper, and glue molecules authoring technical instruction manuals. You know, the information in DNA.
Ink. Sorry, I'm still not understanding this sentence. You're saying ink, paper, and
glue molecules authoring technical instruction manuals. It's the same thing as friggin' ribose, nucleobases, and friggin' activated phosphates writing code. And you're telling me I'm not bright.
Yes, that is what I'm doing.
Yeah, that's right.
Oh,
that's
honestly.
all right. We'll get to that here in a few minutes. We got a couple other issues to go for first.
Jolly good. Yeah, I'm happy to go with your favoured approach. Honestly, why a paper and? Oh right, okay. Paper explanator will be a mod if you can't get anybody else. He said in 10 minutes. Who is it? Paper explanator. He's got a Saturn avatar. Oh, I don't know him. I think okay. He's a nice guy. I'm afraid he's another global earther, but he's one of the again, he's one of the more moderate ones, definitely. That's fine. That's fine. I don't want to shoot you guys. Listen, I was a globe guy for years. I never even thought about it. I don't have anything against you in that. I'm just dealing with empirical evidence. That's all I'm dealing with. Oh, that's fine. That's all right. I don't have any personal vendetta for anyone that, because if somebody would have said this to me, before May 20th, and like I did to them, I laughed at them. And that was on me. Yes, well, you see, that demonstrates, unfortunately, the poor foundations that you've That's right. Got. That's right. You're right. I did have poor foundations with it. And then after I said to myself, well, wait a second, let me check into this, because it wasn't brought up all that much in the forums that I was in. I just happened by this accidentally. Yes, it's not brought much up. It's not much brought up because it's not true. Neither are pixies existing or anything either like that. Or so your defense is not. Well, yes. Given that it's almost as bad as arguing that 1 + 1 is equal to 3. It's not. Almost that bad. No, it's not. Oh, yes, it is. Well, we're going to have you present your scientific evidence, sir. Of course, you don't know what science is, so that's a big problem. Well, I mean, you seem to have read up a little bit on the philosophy of science, but unfortunately, I've read up on it, huh? Well, no, a little bit. Just you seem to have read a couple of Wikipedia articles on the Wikipedia. That's what you do. You're a wiki Google scientist. If it would all of a sudden go down, you wouldn't be on here. No, I mean I've got a background in physics. None of my sources are wiki Google, sir. Well, okay, then they're not actually. I'm saying that they're not actually as good. If you had actually read the Wikipedia articles, you wouldn't be making the basic mistakes you're making. Yeah, the wiki Google. Yeah, that's right. You're a wiki Google scientist. Did you see the Harvard synopsis on using wiki Google as a reference? Have you ever seen that? I have seen an evaluation of it and compared it to other encyclopedias, and they claim in the evaluation that it's almost as accurate as the. Harvard said it's a friggin' train wreck, and you better not use it in academic circles. I got that documented. You want to see that? Well, that would be yes. Well, that's a neutral sort of subject. Yeah, I'd be interested if you could share that. I'm sure people would be interested. Hold on a second. Yeah, it's going to be kind of long in this chat. Do you want me to post it in the chat? Well, can't you? I can share my screen. Yeah, show your screen. That would be the easiest way. I think some other people could see it as well. It'd be silly just to hide it from everybody. All right. There you go. Yeah, if you're going to do academic research and present it as fact, yes. I mean, you wouldn't use it to present as fact. You wouldn't cite it.
This is the big league, sir. We're not playing bets between friends here. This is the real deal. You're in the big leagues now.
Well, not with you, I'm not.
Yeah.
I mean, as I say, about 90% of the completely anything. There are so many basic things you get wrong. That,
yeah, we're gonna see.
Yes.
And
yes,
your generalized, sweeping, baseless assertion fallacies are nonsense. You don't support anything.
Oh, I do.
Yeah, you do. We're gonna see.
But I'm complete. You can understand that Harvard doesn't want people citing.
For a good reason, because it's compromised. They just told you that.
Yeah. So I mean, no one's suggesting that Wikipedia is something that you would cite in a scientific paper. But I think
recommended it as a source.
Oh yes, I recommend it as an encyclopedia. Absolutely, I do.
As a source.
But not as something you
because
reference in a scientific paper. Obviously not.
Of course, because it's compromised.
Yeah, but the studies that have shown that
don't post the studies that have shown it.
Okay, well, the validity. Okay, I'll go and have a look at the validity of studies on the validity of Wikipedia.
Yeah.
I can't remember where I read it. There's an article in White Wikipedia on how reliable it is.
That's good.
Here we go. How accurate is Wikipedia? This is Live Science.
Here
we which
well, I'm not going to punk Live Science out. Sometimes they have some good people on there. I'm sorry, some knowledgeable people. I'm going to punk them out.
Here we go. In 2005, the peer-reviewed journal Nature asked scientists to compare Wikipedia's scientific articles to those in Encyclopedia Britannica, the most scholarly of encyclopedias, according to its own wiki page. The comparison resulted in a tie. Both references contained 4 serious errors among the 42 articles that are analyzed by experts. There we go.
Oh, that's pretty impressive. Somebody better call Harvard then and tell them that they're full of crap.
Yeah. Well, no, I don't think. I think Harvard are prepared to accept that it's whatever the quality. They realise that that it's obviously open to abuse. That it is just because it is a wiki medium. That obviously it can be problematic. So they just suggest you don't.
Well, there are some scientific references in there, but I'm talking about the stuff that isn't referenced.
Well, no, you're talking about you're describing it as a whole.
I was talking now. What I'm saying here is
okay. You're qualifying your previous statement now, are you? Right.
No, I'm not. What I'm saying here is some things are cited in there, but the majority isn't. That's what I'm saying.
So you're saying the majority of articles on Wikipedia pages don't have citations. Is that correct?
Yeah, exactly. That's correct.
Okay. Give me a subject on some scientific subject, and I'll go to a page of Wikipedia, and we'll find out.
Go look at
give me just random subject on science. What would you like? Biochemistry. You come on, buy some biochemistry subject.
I don't.
That you're an expert. That you know something about.
Stereoisomerization.
Right, stereoisomerization. Okay. Yeah.
I was just looking at something. Yesterday.
Here we go. Stereoisomers in Wikipedia. Look at that. And yeah, okay. It's only got one reference on that one.
Like I said, I'm just.
Oh, sorry, two references. Two references.
That's what I'm saying. How big's the page?
Not very big. I mean, it's about two screenfuls. I could share this.
No, I can go in here. I'm on a computer. Hold on.
Yeah, I know, but if other people see it, it's silly.
Oh, got it. All right.
If the people can't see it, so here's the page on stereoisomerism, and I think it's not being presented, so they can't see it there. So there we go. So we tried something there. Okay, only had 2 citations, but that didn't. So that's not. Do you want to try another? Do you want to try again on another subject?
Yeah.
No, don't pick one. No. Okay. Give me. Don't go and look at one and then find. Just go on off the top of your head.
Well, I was looking in there the other day on a subject, and what was I looking at?
Yeah, no, we don't want to go when we want to go on something. We don't want to go on something where you found a problem. We want to
represent okay, you just want me to pop something up?
Yes. Yes.
Hmm.
Come on, that's subject. You know about all this biochemistry stuff you're telling me. Come on, there must be something else you know about biochemistry.
Yeah, there's a whole bunch of stuff.
Well, come on, tell me what. Give me a subject.
Well, we can go with the Krebs cycle.
All right, go with the Krebs cycle. All right, let's see how many citations are on that. There are 33.
Yeah, that's a pretty good one.
Yeah. So you're not doing very well, are you? Already.
What do you mean I'm not doing very well?
Well, you said
the
majority of articles in Wikipedia did not have citations.
Yeah, just no. I said the content didn't have citation.
The content.
Just because there's 35 citations in the document, sir, doesn't mean everything's cited.
No, not necessarily everything.
That.
No, but okay.
Yeah,
well,
right.
so what's the? But there are citations in this document. I mean, it does reference.
There is. I understand that.
Okay.
I've been to Wikipedia before. Yes, I know that.
So I don't understand your complaint then.
I only use Wikipedia strictly for definitions. That's pretty much what I use it for, and even then, I'm a little bit suspect. And the reasons why? Well, Harvard just told you why.
Well, yes, but not. They're more as a principle rather than, as I said, this study showed that it was similar to the.
Well, anyone could add anything to it, sir.
That's the problem. Yes, I mean, I can understand. That Harvard doesn't want people to use it, and I would agree with them. I would say that's not such a good idea, but to use it.
Yeah. Okay. Do we have the somebody? You said 10 minutes.
Yeah. Yes. Flat Earth Debates is in the side chat trying to get Paper Explainator to be the moderator.
What time is it right now? See,
it's now 50 minutes late. Yeah. So Pure and has been a bit poor, hasn't he?
I did have some plans. Let's try to make it quick. It ain't gonna go quick though. I know how this is.
Yeah, it's going to be. Given the fact that I'm going to have to eviscerate you on everything you say, so it might take some time.
Good luck with that.
Well, I haven't had a problem so far.
Yeah, you've had big problems.
I don't think
I'm going to hammer you.
I don't think I recall you making a single valid point in an area.
I don't recall you making one. See, there you go again.
That's because you're not qualified to have an opinion.
Baseless assertions.
But it's a fact. It is.
It's a fact. How's it a fact?
Well, it is. It is. If you were to review it, we would find that's the case.
Support what you say.
I do. Okay, I'm happy to.
Support your ipsy digs aren't support, sir.
Well, okay. Well, we'll see if we can do that.
They're fallacies. They're called generalized, sweeping, baseless assertions. Go ahead and look that up.
It's objective analysis from my point of view, I'm afraid.
Oh, your objective analysis, right?
Oh, here we go.
Paper
is here. Well, I'm matching against the scientific consensus, which is definitely something worth
scientific consensus. Yeah, that's a friggin' married bachelor.
Well, I mean, I suspect. Have you been to university?
Yes, I have. Duh.
Does that just walking through the door?
Yeah,
to study something there.
I'll tell you what, sir. I'm getting tired of your backhanded slights.
They're not backhanded. They're pretty upfront.
Well, you haven't, sir. You can't graduate 5th grade general science in the United States.
Because you say so many obviously wrong things.
Yeah, obviously wrong. Can you support that? So many.
Well, I must admit this. I can't think of anything. Well, I mean, the closed system thing's an obvious example.
Yeah, the closed system. Yeah,
you said a closed terms of closed system, and even though we spent 5 minutes looking through the definition of a closed system, you still didn't seem to understand. And then you would use arguments like, "Oh, well, what happened if it was built one way?" And then you use the argument just in earlier hangout saying, "Oh, but they have to do that to allow them to breathe."
Sure. Well, at least I don't believe ink, paper, and glue molecules author technical instruction.
And the fact that you presented that as an argument suggests that you just don't know how to argue logically. You can't deploy reason.
You have no idea what
there we had a definition of premise. Closed system equals no exchange of matter. In a train, there is an exchange of matter. Yet you said a train was a closed system.
Here we go with your train wreck closed system, right?
I mean, an example that comes to mind.
Just air molecules. That's going to really affect the friggin' velocity, boy.
But that's not the issue. See, yeah, again, you're deflecting. You see, you're getting off the concept. We were talking about what's the definition of a closed system, and you don't, and you can't use the logic.
Yeah, I can't understand it. I know.
No, you seemingly can't.
Because
you can't understand.
Married for love, and Pol Pot was her florist.
You see, you have problems sticking to the point and focusing on the issue, and
we're going to see here in a minute.
So papers are kicking around. Yes, I mean, come on, where's paper got to? Yeah, I agree with Mark. Let's get this show on the road. I think we want to make. I want to be made to look silly about some piece of biochemistry that disproves evolution.
Oh, it's going to be the whole thing. It's not biochemistry.
Okay, no, yeah, but you've threatened me with biochemistry, which is not my expert subject, but I'm more than happy to engage on that.
I didn't threaten you with it, sir. I said,
okay,
do you have any background in it?
You're right. You're right.
I won't bring it up.
You're absolutely right. Actually, I'll take that back. You didn't threaten me with it. You just asked me quite generously. Actually, I must admit that's the most generous thing I think I've ever seen you do in a hangout, was to offer not to go into a subject you felt I wasn't an expert in. So I appreciate that's the first commendable act I think I've ever seen you make on a hangout. So that gives you plus points there. But no, I'm more than happy for you to go for that.
Who cares what you think? I don't care what you think.
You're taking scores off now. Right. Yeah, but then again, I suppose I don't care either. So we're probably equal there. Oh, come on, Pape. Where is Pape?
From you. I got some train wreck statements from you from yesterday. We're going to hit these hard.
Excellent. Oh, come on, Paper. You don't have to come from Saturn to get here, surely. Dearie me. Oh, there he is. He's waiting for a link. He's not been given a link. For God's sake, send it to his YouTube account or his G Plus account on your email. Yes, something. Yes, check the spam folder. Right, so well, someone's failing to communicate with someone. Flat Earth debate. Send it via YouTube. Send it via his G Plus. Send it to his email. Send it to everything.
All right, here we go.
Oh, he's turned up, has he? Hey, it's Paper. Yay. Someone suggested send a drone.
Oh, hi guys.
Hey, Paper. God, honestly.
Well, I offered. I said I couldn't do it for 10 minutes. I needed it to the shop, and that's exactly what I did. And I came back, and I've just literally 10 seconds ago got the link, so I've come in as quick as I could.
I'll be back in a minute.
No, I'm sure you did, Paper. Yeah, I'm sure you did. Yeah.
I'll be back in a minute. Hold on one second.
I don't know what the hell was Flat Earth doing then? Or was perhaps an email system was going down?
They were waiting for Pure or someone, and then they were trying to get Gem Panda.
Yeah.
And could get in touch, and I said I would do it if they wanted me to. I mean,
yeah, that's the one. Thanks, Paper.
So you guys going to do the talking?
Yeah, it's right. You just have to. Yeah, I think yes, that's right. You're just going to have to keep John under control, I think.
Well, both of you.
Yeah.
I've got to be impartial.
Yeah, that's good. That's
you know my position, but I will remain impartial.
Yeah, actually, yeah, Paper. I think you've demonstrated an ability to be impartial when required.
All right, I'm ready.
Okay, so what format are we going to go? Are we going to go sort of 5 minutes each way, then a rebuttal, or do you want 10 minutes each way, then a rebuttal? How do you want to do it?
No, we agreed that we were going to go on the things that were said yesterday in the hangout.
Okay.
Perhaps if it gets troublesome, perhaps we go for sort of 2 minutes each or something, swapping. So I think we'd keep. I think it'd be bad if we just had 5. I don't know. I suppose it depends if we haven't quite got a prepared sort of statement.
We'll sort of suck it and see then, shall we?
Yeah.
Let's have John try and stick to one issue at a time, then, shall we? And we'll just repeat the process. Is that okay?
Oh, that's good.
That's fine. Yeah.
Sticking to the thing.
Like I said, I got them separated. So.
Okay. So obviously. We'll give John 2 minutes to say whatever he wants to say, and Rumpus, I'm sure you're going to be desperate to jump in within the first 5 seconds, but try and keep obviously completely quiet for a full 2 minutes. Let him make his point, and you'll have your 2 minutes.
Okay, thanks, Paper.
Okay, I'm going to set a little timer for
right, well
a couple of minutes to make your point. Obviously, 2 minutes isn't a long time, John, so it's got to be fairly concise. But 2 minutes, over to you. Go.
Yes, Paper said yesterday that scientific theories can be the first step in the scientific method. I'm sorry, not Paper, but Rumpus.
Rumpus.
So scientific theories can be the first step in the scientific method. Can I share my screen, please?
Yeah, I'll present you. I haven't got mods by the looks of it at the moment. Let me just stop your clock.
Okay, appreciate it.
It would appear. Doesn't look, I haven't been given mods yet.
Paper's not. I mean, sorry, flat Earth debates.
No,
not
right. Okay, I've got mods now. Okay,
great.
so I'm going to present to everybody. There you go, John. Right, your time. I'll
Reset it.
I'll reset it. Yeah.
All right.
Right, go again.
All right. Like I said, Rumpus said yesterday that scientific theories can be the first step in the scientific method. See, this is the scientific method right here. And what's the first step? It's to observe a phenomenon. And the reason why this was made up, the scientific method, it was to rid the world of myths, consensus, votes, majority, and opinions, and loudest voices. The subjective, in other words, by establishing a method that solely focuses on the empirical, observable, testable, repeatable, and falsifiable, the objective. So another problem is he doesn't understand what a scientific theory is as opposed to a colloquial theory. A colloquial theory is abject speculation. Scientific theories explain the how and the why, the mechanisms and the process, like germ theory. Scientific theories are the result of validated, confirmed scientific hypotheses. They're the result of this. They're not part of it. And as you can see here, I got 3 sources that tell you what a scientific theory is. It summarizes hypotheses or a group of hypotheses that have been supported with repeated testing. All of them say the same thing. Observe a phenomenon. The scientific method has 4 steps. Step number 1, observation and description of a phenomenon or a group of phenomena. That's from physics lab at the University of Rochester. In the scientific method, the first step is an observation. The first process in the scientific method involves observation of a phenomenon. A hypothesis is a tentative explanation for an observed phenomenon. You make a set of observations, then hypothesize an explanation which accounts for all the observations. No phenomena is a phenomena unless it is an observed phenomenon. Niels Bohr, as quoted in Science and Ultimate Reality.
That's your 2 minutes, John.
There you go.
Okay, now let me I just want to get. Is this flat Earth against globe Earth? Is this right?
Yes.
Okay, so you didn't. Okay, I just want to. You talked about the scientific method, but you didn't actually bring any evidence of the flat Earth there. So it doesn't really.
Yeah. Well, this is the baseline. You have to, if you're going to provide scientific evidence, you have to know what science is.
So, do you want your time extending and then let Rumpus have the extra time as well? So you want to finish your point, or do you?
No, I think I finished. No, that was I think I finished my first point.
Okay, Rumpus, are you there?
Yeah.
Okay. Do you want to sort of rebut that in a couple of minutes?
Well, there's no rebuttal. I mean, there's no dispute about what a theory is.
Okay.
I've made exactly the same arguments he's just made there to many people over many years. We all know that a scientific theory. I've had to explain to other people who get confused about the colloquial definition that a theory, the scientific theory, is in the general relativity theory or special theory of relativity, is the result of observations, hypotheses, testing things, and then when they become accepted by the peer review, they then become a theory. It's the highest, it's the pinnacle of the scientific process. It's the highest status that something can have. Something like a law, for instance, is an observation of what is basically an observation. So the law of gravity, that we see things dropping to the ground, whatever, and laws revolve around the data that you have. The theory is one level above where you try and explain that law that you've acquired. So as per usual, John spent, I don't know, 2 minutes just wasting everybody's time. The only thing I did say, I did say that you could start off with a theory. I did and that was in the colloquial sense, I must admit, because it is very easy to flip between the two. But John, you see, this demonstrates, I'm afraid, that John seems to have a sort of Wikipedia idea about science. He's learned a few things, and then he hasn't got the flexibility because he doesn't understand it. And he seems much more interested in the philosophy of science than actually doing science, which is what people do. If they can't do science, they do the philosophy of science. And I'm afraid John is an example of that. I did say that someone could have a theory without having, but that's usually because there's something like the universe. You say, well, I observe the universe. Everyone's already could start from that point. And if you take, I was taking that as as an accepted context. So you could then without having, so something like, I suppose even Einstein, although he didn't have any references, he was talking about observations. You could come up with a theory of the way, for instance, the way the universe has come about by just simply saying I can see reality. Now you could argue that that is an observation, that the phenomenon is the observational.
Okay, 2 minutes gone.
Okay, go to 10 more seconds.
Yeah, 10 more seconds.
And then you could then, so that if you're prepared to say reality is an observation, then there are lots of theory in the colloquial sense of theory you could just come up with to say explain how the universe came about. So
okay,
he's got half a point.
Okay, stop you there. Okay, John, you there?
Yeah, I muted myself, sorry.
Yeah. Do you want to continue for another couple of minutes and further your point, or do you want to move on to something else?
I've got other points. I just want to know how he knows where I got and when I got my information from. And number two, the point was, he said scientific theories can be the first step in the scientific method. That's what I was refuting. So it's wrong. He's refuted.
Okay. Rumpus, want to respond to that?
Yeah, and as I said, it's very easy to flip between the colloquial sense and that, because I obviously was not referring there. There's a theory in the scientific sense, but it is just very easy to slip into the colloquial sense of a theory. And I've repeatedly said many times that scientific theory in the scientific sense is obviously the result that John spent 2 minutes talking about that we all know. But I was saying that you could have a theory in the sense of a colloquial sense, as in a hypothesis about if you're armed with nothing more than the observation that you exist, but taken that as a sort of understood premise, a context. And I thought that didn't really include that, therefore, as an observation, really. As a more general case, I exist, therefore you can then have a hypothesis about existence. And I would argue that reality isn't really much of an observation in the sense of, I observed the thing he stated as an observation. So I think from some very metaphysics is that okay.
John, do you want to move on to a point which actually more directly, rather than discussing what the theory is? I mean, there are two definitions to a theory. I don't know if you're aware of that, but anyway.
No, there's not. There's only one definition to a theory.
No, if you look at a dictionary, you'll find there are several.
Scientific. I just posted them for you. There they are, right there.
Yeah, scientific theory. Yes, there's a scientific theory. But if you look up in a dictionary and in conversation, people say I have a theory about something when they're using the colloquial sense.
We're not talking about that. We're talking about a scientific theory.
Yeah, but I mentioned that when I slipped into using the colloquial sense in the discussion that you're talking about.
Okay, guys, shall we let John move on to a more
scientific? How about instead of the philosophy of science, how about doing some science?
No, we're going to do some right now. You have to know what science is first before you can do it.
How long do you want to make your next point, John, to get your
2 minutes.
point across? Two minutes, okay? All right, go.
Okay, he said that there's no independent variables in scientific hypotheses yesterday. So, construct a hypothesis. A scientific hypothesis is your experiment statement. It expresses the proposed cause and effect relationship, the phenomena that was observed in step one. It's a classic if this, then that motif. The independent variable is the proposed cause that you will test to produce the effect. The dependent variable, your prediction, you observed in step one. You must have a viable independent variable, i.e. you must isolate the cause. So forming testable hypotheses from California State University of Berkeley. The key word is testable. That is, you will perform a test on how two variables might be related. This is when you were doing a real experiment. You were testing variables. Formalized hypotheses, let's go down here, contain two variables. One is the independent, the other is the dependent. Notice there are two parts to formalized hypotheses. The if portion contains the testable proposed relationship, and the then portion is the prediction, or your dependent variable, of expected results from an experiment. An acceptable hypothesis contains both aspects, not just the prediction portion. Here at Chemistry About, the independent variable and the dependent variable are examined in any experiment using the scientific method. The independent variable is a condition that you change in the experiment. It is a variable that you control. The dependent variable is your outcome. The null hypothesis from sciencenotes.org. The zero difference or no difference hypothesis predicts that changing one variable, the independent variable, will have no effect on the variable being measured, dependent variable. So how on earth can you have a null hypothesis and have no independent variable? Is this clear?
Okay, that's your 2 minutes.
Thank you.
Right. Well, again, he's just using a subset. I mean, again, he's not interested in talking about science. He's just talking about the philosophy of science. So, for instance, something like the focal pendulum, I don't have an although he denied that you do have an independent variable in the sense of where you set up your focal pendulum in terms of latitude. But that's, you can still have a perfectly reasonable experiment by setting up a focal pendulum somewhere in a latitude, and then there you go, and then saying, without being able to change the latitude, saying, I'm going to make a prediction, given that I understand that there's a rotating Earth, that the pendulum will swing in such a way. And then you match that prediction against. So the null hypothesis would be there would be no, for instance, the focal pendulum would not change its orientation with respect to the Earth. And then you can say, right, but I believe there's a spinning Earth, and therefore I predict that there will be a change in the swing of the pendulum. I haven't had to change any independent variables there. And that's still a perfectly reasonable scientific thing that I'm sure. I don't know who, but there was a paper. I think the papers were the first scientific journals in 1694. I think the focal pendulum was 1850. Oh God. Anyway, so I'm quite sure that if someone wanted could perfectly acceptably claim that it's a scientific experiment to set up a focal pendulum and then say make the prediction and not being able to change any independent variables whatsoever, but make a prediction about what's going to happen and still have a null hypothesis. And then when, of course, you do get the deflection, you say that confirms my prediction, that confirms we're on a spinning Earth. And that did not require an independent variable. So the fact, this is just not quite, it's not gibberish, I'd agree, but there obviously is a subset of experiments where you have in the lab where you obviously try and modify the environment, this independent variable thing. But because, unfortunately, John's got such a limited understanding of what's going on, he just picked up these odd little key little elements he's interested in, and he can't focus on the bigger picture.
Can we keep the personal attacks out of this and just deal with the subject material? Thank you.
Okay. So there's no independent variable, and yet you can still have an experiment. Case solved.
Yeah, okay, and I just showed you
2 minutes there. Okay, so
I just showed you the direct opposite of that, sir. Cited from here till the cows come home. And what's your independent variable with your focal pendulum?
Exactly, there isn't one.
And what is the dependent variable?
There isn't. Well, there is a.
Well, then it's not an experiment. I just showed you.
Well, I've just demonstrated that it is.
You didn't demonstrate it. It's nonsensical. What are you manipulating, sir? And what is your prediction?
You don't seem to listen to half the things they're told. I don't know whether this is a problem you're processing information or you just don't listen. I just demonstrated the null hypothesis. Would there be no deflection of
You don't have a hypothesis first to do a null.
Yes, the hypothesis is that it would change the orientation of the swing of the pendulum with respect to the Earth. That's the hypothesis.
What are you manipulating?
Hold on. You're not manipulating anything. That's my point.
You don't have an experiment.
Yes, I know. That's what you're claiming, and you're wrong.
You don't have an experiment.
You didn't listen. You didn't listen to what I said about the null hypothesis. I explained there was a null hypothesis. You said, "What's the prediction?" You didn't listen to what I said. You didn't listen to the fact that I explained there was a prediction, so you didn't hear that or understand it either. That you would expect deflection. Well, the evidence is in the Hangout.
What does this say? The independent variable is the core of the experiment.
Can I just finish my sentence? You asked me where was the prediction, why was the null hypothesis, and in the previous statement, in the 2 minutes I had, I explained exactly those words.
That's not the argument. Focal pendulum wasn't the argument. You said there are no independent variables in scientific hypotheses, sir.
I did never have ever said that.
Yes, you did. No, yes, you did. You said it yesterday. Not. I wrote it down.
No. I said
go back and read it.
I said it doesn't have to be.
Go ahead and read it.
Well,
Yes, there does. It does have to be.
No, I've
because
just
that's the
explained.
definition
I've
of a
given you an
scientific
example.
hypothesis.
I've just
sir.
given you an
I just
example
read
where
it
you
to
don't need one.
I just read it. That's right there.
Yes, and I'm disputing that as valid.
You're disputing that with what? Nuh-uh.
I've given you an example, the focal
That's
pendulum.
not an example that you conjured. I asked you what the independent variable was with your focal pendulum that you just conjured.
And I've now answered that 3 times, and I'll do it again.
And what are you manipulating? What is the cause and what is the effect?
Right. I've said, and I'll say it for the third or fourth time now, you could have an independent variable changing the latitude of your focal pendulum, but I'm not suggesting
you control.
Hold on. I didn't get my rest of my sentence out. I'm not suggesting you need to
write
do
it down.
that.
Go ahead.
Right, I think we're getting into an argument about sort of semantics and definitions.
No, it's not semantics and definitions. No, it's not.
If I could just finish. So you do actually have an independent variable, the focal pendulum, but I'm saying you do not need to exercise that option because obviously, something like a pendulum, you might not. Well, you can still get. Hold on. I'm being interrupted here.
No, I just want to make sure. I want to clarify. Your independent variable. Is
how about clarifying? I was going to do one sentence, and you can ask me for clarification.
Let me finish, John.
Okay.
Right. So with a focal pendulum, you can still do science, even if you don't change the latitude, which is effectively your independent variable. But I'm saying you don't need to exercise that option to conduct an experiment, to make a prediction, to have a null hypothesis. You didn't listen to any of that because you then asked me what those were again, because I don't think you seem to be able to take on board information and you're just demonstrating it again.
How does he know I didn't listen to it?
Because you asked me the question. You said, what's the null hypothesis? What's the prediction? Even though I told you that
I didn't
beforehand.
say the null. I didn't say the null.
You did.
I asked you what the independent
you asked me for the null and the prediction.
No, I didn't. I didn't ask you for the null. I asked you what your independent variable was, and you said the focal pendulum. So the cause is the focal pendulum, and your prediction is what?
Oh my God! I'm gonna have to. So
it's nonsensical buffoonery, is what it is. Go ahead.
I don't. But this is the problem. You see, this is why I know you don't. You've never had to exercise your brain properly because you can't take on board information.
We're done with that one.
And I'm going to say it again. I'm going to say it again. You have a null hypothesis.
Right, I'll stop you both. Right, John. Are you saying, just for clarity, are you saying that the focal pendulum is not a valid experiment to prove something?
Yes.
That's what you're saying. Okay.
That's exactly right.
Okay, right. That's your opinion. Okay. I think
that's my fact. I just showed you why.
I see. Okay. Can you say why then? Can you just elaborate on why?
Yes, because it's not a viable independent variable. Your independent variable is the cause. The dependent variable is the effect. So the focal pendulum is the cause of what?
No, the focal pendulum is an apparatus designed to demonstrate a phenomena. I'm
not debating you, sir.
Yeah. I know. That's what I'm saying. I think the physical thing, the focal pendulum, is a physical thing. It's not a variable.
That's right. That's what I was saying. So it's not a viable independent variable. You got it right.
Okay. Right. I think we better move on to another point.
I just want to say a couple of things there.
Let's move on.
Oh, no, I've got to say, because he's being such an idiot.
Rumpus.
Can we stop the name calling, please?
I've got to pull you up on that, Rumpus. You do tend to say, he doesn't understand it because he's an idiot and things like that. We don't need that, Rumpus.
Okay, well, it's very difficult to resist.
I know, but you're not going to achieve a thing.
Yeah, because he has no other recourse. Right. He can't support his.
Okay, well, let me just do this once more time. I'm going to explain to him.
We're not going to listen to one more time. You already explained.
No, we are, because that's what I want to say. There is an independent variable, as I've now said about.
What is it?
Right. I was about to say, but you interrupted me.
Oh, yeah. What is it? It was the focal pendulum before.
Moderator, I'm in the middle of a sentence here explaining exactly the thing he's asking.
John, let him have 30 seconds, and then we're going to move on.
Right. There is an independent variable, the focal pendulum, and I'll say it for the 5th time, and that is the latitude that you decide to mount the pendulum on. Okay. Right, hold on. I haven't finished. That's not 30 seconds. And I'm saying, but you don't need to actually have an independent variable to be able to make a prediction about what's going to happen and have a null hypothesis. And therefore, it is science and it is an experiment, even if I choose not to exercise the independent variable. Thank you.
Right.
And I just showed you that an independent variable is absolutely necessary in a scientific hypothesis.
You've got some quotes there. I'm sure.
I just showed you.
Yeah, you've just showed some quotes. And I've just demonstrated by an example how you don't need that.
They're cited references, sir.
Right, I'm going to stop you both. Right, we're not this particular one is going to just go on forever because there's
Okay,
a
let's go. Let's
disagreement in
move on.
terms here. Okay, so let's move on to your next point of your two of 7, John. Yeah.
Okay.
I'll give you 2 minutes. Okay.
Okay. He said yesterday that I said that time is not physical. It has no physical attributes.
Rumpus.
Sorry.
It's a concept. That's what I said. Physical matter. I got the definition for you right here. Matter, any substance which has mass and occupies space. All physical objects are composed of matter, right? So number one, what is the chemical formula of time if it is physical? Because that's your position. And number two, what phase does time exist in? A solid, liquid, gas, or plasma? Or does it depend on the time of day? Go ahead.
I never expressed an opinion about time in the Hangout. Yes, you've got me confused with someone else.
Yes, you did.
No.
Yeah, because I explained Einstein, how I clobbered Einstein's theory, and you said that's baloney.
Are you giving up? Are you relinquishing the rest of your 2 minutes, John?
Yes.
Okay, right. Rumpus, 2 minutes.
Yes, I don't have an issue. I've never said time is physical. Never. Yes, I don't know what John. Unfortunately, because he can't apparently import information, he's got it wrong again. I never said that. I don't know what. I'm not quite sure what I think time is. It's something I've thought about it. But I've not made any claims at all about what it actually is. I'd probably say it's not physical. We did have a debate yesterday involving, but I kept well clear of that debate yesterday. So the concept of time, again, this is all, again, philosophy of science, not actual science. He's not interested in talking about science. If I just got it.
Yeah, sure.
I'll try and put a time. If I had to be forced to take time, I haven't formed an opinion about what it actually is. I would probably say, though, it's not physical. So this whole point is irrelevant. One thing I would like to say is all physical objects composed of matter, he says, in the form of atoms. Well, not everything is physical and composed of matter is form of atoms. So he's wrong about that, of course, because there isn't anything about science.
All physical. Please keep your comments to yourself. All physical objects are composed of matter. Period. End of story.
Yeah, but you said in the form of atoms. Concept. There are lots of things that aren't atoms that are matter. Muons, mesons, tau, tau particles, mu mesons.
Okay, you said yesterday that time is not physical. You can go back and review what you said in the Hangout. No problem. Let's move on. You said.
I didn't. You're confused, as per usual.
No, I'm not confused. It's in the Hangout. I wrote it down when you said it.
Well, whoa. Stop. Rumpus, you've still got 10 seconds if you want them.
Oh, right. Yes, so he's got that completely wrong. So his statement there about what matter is completely wrong. And anybody who knew anything about the subject wouldn't. You see, this is the problem. He's suffering from Dunning-Kruger, and he's writing these things down that he doesn't know anything about. And he's got the confidence of ignorance.
Okay. Hey, what's up with these personal attacks?
Yeah, keep telling you, Rumpus. It's not getting any. That doesn't achieve anything.
That's all right. He's just showing his hand. It's called a tell. He has no recourse. Okay. But that's all right. Let's go.
Okay. Do you want to move on to a third point, or do you want another 2 minutes on this subject, John?
Yeah, it won't take 2 minutes.
Okay, go ahead.
You said yesterday, Rumpus, there's no problems with Einsteinian relativity and quantum mechanics together. Right?
I said exactly the opposite.
No,
Jesus
you said it yesterday.
Christ.
No, you did. That's all right. We can go back and review it because I wrote these down.
This guy is an absolute moron.
Yeah. Here we go again, moderator.
Yeah, Rumpus.
Sorry.
It's.
But when someone's saying something's completely wrong for the second time, it's just tell him
he's wrong. Then don't call him a moron.
Right.
Right, carry on, John.
Okay. Now he said he didn't say it, whereas I wrote it down yesterday when he said it. So we have a anyone could go back and review yesterday's Hangout and see what he said. So.
Okay, so what's your issue with?
Well, okay, okay. I mean, I may have expressed that when I said there's not a. Okay, I mean, I might not. Okay, perhaps I'll withdraw slightly. What he's building up to is as I explained to him, that physics and the physics debate, the biggest subject is the problem about the incompatibility of general relativity and quantum mechanics. And I went on about this at length yesterday. Now, so when I say, I may, that phrase. So I went on at length for how there is this incompatibility between the two. So for him to quote me as that somehow representative of what I'm saying is absolutely outrageous. It's the biggest subject in physics, the fact that we do not have a model of physics which brings together the quantum mechanics with general relativity. This is what string theory was all about. Supersymmetry was all about. You can go to any program, any book about physics on the sort of general subject, or even watching a program about it. They go on. Brian Cox, I don't know if you get that in America, goes on about it all the time. This incompatibility between general relativity and quantum mechanics. They don't match. We can't get them to. And this is what M theory and string theory is all about. I went to this at length yesterday,
Those aren't theories,
trying to
sir.
bring these things together so that
Those
we
aren't
do have a
scientific
unified.
theories, sir.
This is what the theory of everything is all about. It tries to bring together Einstein, the general theory of relativity, and quantum mechanics. I mean, I went on about this at length, and for him to then suggest here that there's no problem with bringing them together when this is the biggest subject in physics, it's just ridiculous.
Sir, that's what you said yesterday. And string theory and M theory aren't scientific theories, sir.
Oh my God.
Okay, so as a result of that, John, do you want to make a point about it?
Yeah, but we can move on. I already made my point there. We can go on to the next one.
Okay, right. I'll start you 2 minutes. Make your next point.
Okay, he said materialism and realism is true. And what materialism and realism is, the doctrine that the world is, there's a world of matter existing independent of perception and consciousness. But, as we see here from Bernard de Espagna, the doctrine that the world is made up of objects whose existence is independent of human consciousness turns out to be in conflict, again, with quantum mechanics and with facts established by experiment. So that refutes that. Here's another one. Quantum theory thus denies the physical world independent of its observation. That's at Rosenblum and Kuttner in The Quantum Enigma. Professor Henry Stapp, he gave a United Nations briefing. He said, "You often hear that the observer was brought into physics by quantum mechanics, but it was not a passive observer. Quantum mechanics brought the human being into science not only as an observer, a passive observer, but as an agent." And that is the key point. In order to make quantum mechanics work, you've got to bring the human agent into the equations of quantum mechanics, into the dynamics at the outset. The atoms or elementary particles themselves are not real. They form a world of potentialities or possibilities rather than one of things or facts. That's Werner Heisenberg. There's the citation. The path taken by a photon is not an element of reality. We are not allowed to talk about the photon passing through this or that slit. Neither are we allowed to say the photon passes through both slits. All this kind of language is not applicable. That's Professor Anton Zellinger. And the coup de grace from Zhao Song Ma. Quantum erasure with a causally disconnected choice from Pinas. No naive realistic picture, that's red, realism or materialism, is compatible with our results, because whether a quantum could be seen as showing particle or wave-like behavior would depend on a causally disconnected choice. It is therefore suggestive to abandon such pictures altogether.
Okay, right, John. That's fine. Now, I haven't heard the shape of the Earth being mentioned at any point yet.
Right. I'm happy to go through those quotes.
Sure.
If you could show them on screen.
Sure, they are on screen.
Yes. I thought you were about to make the window small.
Go ahead for a couple of minutes then, Rumpus.
Yeah, I mean, it would be nice to get onto the flat Earth, because that presumably is what Flat Earth debates is interested in. But yes, I mean John's basic claim is that that humans are required. Now, it is perfectly compatible to say that human consciousness is an agent in the experiment, but what is not correct to say, it's a necessary part. Now, I think there was some statement in order to make quantum mechanics work, you've got to bring the human agent into the equation. So down there, just in the third quote, in order to make quantum mechanics work, you've got to bring the human agent into the equations of quantum mechanics into the dynamics. Right? I don't believe that would be accepted. I think that's just wrong. Now, the reason, of course, that John is interested, he believes that the quantum mechanics can only work with an observer, a human consciousness or some sort of consciousness. Now, this came but through, I think it's about the 1960s, where you may have heard that there has to be an observer. And in the 1960s, there was a suggestion, I can't remember, by someone called Winger. I've got that somewhere. Hold on, just give me a couple moments. Winger, I don't know if that's how you pronounce it, it's German. And he suggested that you needed a consciousness to collapse the wave function, which of course is something we possibly could talk about. The Schrödinger wave equation, which is this wave equation that basically gives particles the instructions about where to go. So something like the double slit experiment that you hopefully people are familiar with, in this way you have two slits very close to one another and you shine light through them, you get an interference pattern, you know, like just as if you did it on
15
water.
seconds from
Oh god, this is quite complicated. Yes, you see, he's just where was I? And this chap in 1960 claimed that you needed a consciousness, an observer, a conscious observer, not just a detector, not just a piece of kit. Oh God, can I just finish off my sentence?
John, is it all right if Rumpus carries on for another 30 seconds? Yeah, go ahead.
That's fine.
Thank you. Thank you. Because it's a huge thing that's been brought up here. And so this chap, because he thought that because the whole point about the Schrödinger wave equation is that you have a superposition of possibilities, and he thought, well, that your consciousness does not have a superposition of possibilities. You see just one result, and because of that, he felt that that was where the superposition of the Schrödinger wave equation stopped at your consciousness. But he's actually retracted from this now in his later life. I don't know whether he's dead now or whatever, but he's certainly in his later life. He's now said no. He's recanted that position, that you do not need consciousness, because people like Roger Penrose, who people should well know from Black Hole, is associated with Stephen Hawking, pointed out to him that in fact your consciousness can in fact cope with superposition. So the reason this consciousness came, as I was saying, is because the idea was that your brain, your consciousness, was a classical thing where you couldn't have superposition, and therefore everything up to the point, because the detector could have subject to superpositions, and a kit you might store stuff on might have superpositions, all the way up to consciousness where they said, oh, this is classical, your perception is a classical perception, you can only have it one way or the other, therefore that's the point where the Schrödinger wave equation must be resolved one way or the other. And he just came with this as an arbitrary philosophical idea, and it was accepted by many people, and that's why you'll see this idea of a big eye looking at the universe to make it work. And this is the point that John's very keen on.
Okay.
But just one last sentence. But he recanted on this, and Roger Penrose pointed out that the brain is just like, just a collection of atoms, and therefore can in fact work in a superposition state. And therefore, this whole idea of a conscious observer being required to make quantum mechanics work, I'm afraid, has been kicked in the bin. So, and this chap that he's got a quote from there, I'm afraid I think there'll be lots of physicists who would disagree with that.
Okay, that's enough, right? I mean, you've been going on for a while now.
Thank you, John, for letting me finish that. But you
haven't supported anything of what you said, so let me take it to the woodshed right now. Can you see this?
Well, I could give you a quote from Wigner if you like. I
don't need quotes from Wigner. This is an actual experiment. The presence of path information anywhere in the universe is sufficient to prohibit any possibility of interference. It is irrelevant whether a future observer might decide to acquire it. The mere possibility enough. You see this?
Yes, and yes, but that observer doesn't have to be conscious. The observer doesn't have to be conscious. It could be just a piece of
path information. Who is able to know the path information?
You don't need to know. No one needs to know anything. No one needs to know anything. It could be just a piece of. It could be a piece of measuring
right here.
It could be a piece of measuring kit. It could be a piece of measurement.
You're refuted in this experiment right here.
When he talks about future observer, that could easily be a piece of mechanical kit.
No, it can't. You're talking about decoherence. That's all right. I'm going to deal with that here in a minute.
That's what I'm talking about, decoherence, yes.
Yeah, you are. We talked about that yesterday. That's okay. We're going to get to that here in a minute.
So the nothing you've just said there in any way contradicts what I've just said.
Sure, it just did, directly.
No, it doesn't, because I've just pointed out an observer can be a piece of kit.
Yeah, it did. Yes, it did.
No, it didn't, because you got to, an observer can be a piece of mechanical kit. It doesn't need to be conscious.
No, it can't. Well, who made the mechanical kit?
It's irrelevant.
Okay, we're going to see that right here in the delayed choice.
Well, what about the previous 3.5 billion years when humans weren't around? What do you think? 3.5 billion years. The universe managed to exist in that time.
Scientifically validate that, please. That's a claim. You have to support it.
Okay, right. If you want me to, do you want me to spend a couple of seconds on that?
No, I don't. We could get to that at the end.
Well, you just asked me to support. Now you're saying you don't want me to. Make up your mind.
Yeah, we can support it at the end. I'll mark it down.
Okay, so you don't want me to support it then?
Yeah, I will.
Well, make up your mind. Tell me what it is you want me to do.
I want you to support it. We'll do it.
You do want me to support it? Jesus Christ!
At the end.
Oh, at the end, not now. Jesus.
That's right.
Right.
I write it down.
Guys, can we please possibly move on to something that actually remotely represents the discussion on whether the Earth is flat or spherical?
No, this is material to the discussion.
Okay, so
this is material to the discussion, sir.
At what point are we going to move on to flat Earth?
He said, I'm not done yet.
Right. But I mean, I say we can go on for hours and hours and talk about, not
we
flat
agreed to, but he agreed to this before we started this hangout that this is how we were going to structure this.
No, the structure is the time each of you get and the way you rebut things. But the conversation, I mean, you could talk about line dancing. No, we're
not talking about line dancing. This is science.
Talk about flat Earth.
He made claims yesterday, and we discussed these as the subject for our discussion today before you got in here, and he agreed to them.
I did agree to take your 7 points. I mean, it would be nice. I didn't agree to you being able to completely set the agenda, but I was happy to go through your 7 points.
Now you're.
Well,
do any of the 7 points relate to the shape of the Earth, John, or not?
Yeah. Listen, I'm not done yet, sir.
Yeah,
I have 2 more points.
Okay.
They're going real quick.
And then we can move on to flat Earth.
Possibly.
Well, I thought that was the idea of the debate. I'm sorry.
Sure, it'll be real. Yeah, we can move on. Listen, can I finish my points, please?
Yeah, go ahead. Give you another 2 minutes.
He said yesterday, as we were discussing the delayed choice quantum eraser, this experiment right here, which I'm going to take his decoherence nonsense to the woodshed here in 1 second. He said, I haven't reviewed this experiment, but if you're saying it shows retrocausality, you are sadly mistaken. So let me get this straight. You haven't reviewed this at all, but you're willing to come to a hard conclusion about the experiment, about the results of the experiment. So,
yes.
I mean, how did you get did you use like tea leaves or, like a crystal ball or something to figure that one out? It's probably the same method you use to arrive at your worldview.
Right.
So I'm going to show you how it does affect causality, if you don't mind.
This could take some time.
And to your point, let's just talk about decoherence for a second. You said any detector will cause wave function collapse. But as we can see here, you see these D2 and D1 detectors downstream from the double slit? It's going through half silvered mirrors and bouncing off full silvered mirrors. I mean, these are actual physical things that it's coming in contact with. However, guess what we're getting? Interference patterns at R1 and R2, sir. What's going on? I thought you said it would collapse it. I'm
afraid I haven't had time to fully review this experiment again, I'm afraid.
Well, you already came to the conclusion that it doesn't.
Because the conclusion that you came to was that retro causality is clearly...
Okay, I'm going to show you that right now.
Well, hold on. I'm just saying the reason I rejected it. I mean, I did reject it. I said, but that's because on a grounds of authority. There are people that I trust, and just the academic institutions and the positions they hold. I have confidence in their answer, and therefore, although I don't have.
That's appealing to consensus. You don't have.
I'm appealing to not just it's not just consensus of people I met in the pub. This is the consensus, the scientific consensus.
No, it's not.
And
consensus doesn't have anything to do with empirical science, sir. Consensus is subjective. Empirical is objective.
Yeah, but there are people who I trust to have a good opinion
about this.
I know, and they're capable of evaluating the merits of this experiment better than I am at the moment.
I just evaluated it for you yesterday.
Yes, but
I'm going to show you retrocausality.
You can't even remember what happened yesterday. I wouldn't trust your evaluation of whether your trousers are on the right way. I'm going to show it to you right now, and then you can either comply with it or do another Ipsy-Dixit fallacy. Because you said so. It's a nuh-uh. So listen, photon is generated here for an argon pump laser. There's no detectors here at the double slit. All the detectors are downstream. The entangled photons are split.
one photon, the signal photon, is sent to D0. All position measurements are measured here. The idler is either going on the red path or the blue path. Now this signal photon arrives at this detector 8 nanoseconds before any of these detectors get hit. That is, you see my cursor right here?
Yeah.
And right here?
Yeah.
That is, D0 is hit before any of the idler photons hit BSA, the half-silvered mirror, or BSB. It has no idea. Every single time that we take measurements or hits at D3 and D4, this shows wave function collapse. Every time we take measurements here at D1 and D2, these show interference, but they're shown at 8 nanoseconds before they even reach these detectors. This is what you're getting.
Yes,
from the unknown path. And as you can see, the difference between D3 or D4 and D3 and D1 and D2 are, we know the path information to these detectors. As you can see, the only way it can hit D4 is if the photon came out of A. The only way it can hit D3 is if it only came out of the blue path, right?
I think this is going to be an unproductive thing. I mean, you've missed out a couple of important things, like the crystal. That's
like
the key thing about where we got these two lines.
Yeah, the BBO crystal. Yeah, so
yes,
those are entangled photons.
Yes, I mean, there's a lot of information you're missing out on this, and I haven't.
Okay, you know what? Do you want to go through the whole thing then? I got to write up with it.
Well, I have not done it enough. So
Here we go. Do you want me to start off?
Well, I think if you're going to explain it in the level of detail that I'm then going to form an opinion, it's going to take us an hour. So I don't think this is a productive way to spend our time here.
Well, you're quibbling over how you got the entangled photons. I got it right here.
So right.
What does that have to do with the experimental setup or the results? They're entangled photons.
Okay, right. But okay, well, it's just the way you're explaining it is not. I don't think you're very good at explaining it, because I don't think you understand.
There's another opinion again.
But
you said yesterday that you knew that.
No, I didn't say that.
Before even reviewing it.
No, I'm expressing an opinion about it based on my confidence in the scientific.
But you never reviewed the experiment. How can you make a hard conclusion when you never even looked at it?
I gave my belief.
I want to quickly interrupt. What does this experiment show, John?
It's this retrocausality is the object of the exercise he's trying to demonstrate.
It shows retrocausality. Here's the results of the experiment.
I mean,
the existence of the experimental conclusions. The existence of the Witch path information alone causes wave function collapse. So, and then here's his appeal just before to decoherence. The physical interaction with the measuring device does not cause wave function collapse. I just showed you that.
Well, I'm not. You haven't. I have not understood.
I just showed you. Here you go.
No.
Here's the interference pattern.
Right. Well, I would need to review this in some detail to form an opinion, and I can't do it now. And it's going to take us an hour to go through this for me to understand to the point.
Now he asked me the question. So number 3, QM phenomena transcend time and space, and we have another.
There are scientists that are familiar with this experiment who do not agree with the conclusions you're offering.
It's not a case of agree or disagree. It's empirical.
No, it's not.
Yeah, it is. It's an experiment.
That's the point. There are scientists who empirically say it's not.
And sir, well, they say that, but they can't support it by experiment. And I have it repeated right here by orders of magnitude that time and space, this last one right here, transcend time and space.
Well, you've written something down there, yes, so what?
Zhao Sung Ma, but this is quantum erasure with a causally disconnected choice from PNAS. They took this experiment a step further. Instead of 8 nanoseconds, they did it 5 orders of magnitude further on the time end. That's 450 microseconds. And then on the space end, it took it to exponential magnitudes with 2 experiments, one at 55 meters, one at 144 kilometers space separated. So time and space are utterly meaningless in quantum mechanics.
They did this experiment with a separation of 144 kilometers.
Yes, they did on the Canary Islands. Here, I'll put this in the side chat. You can review it at your leisure.
Okay, well, I really don't think we'll get very far. I think this is such a detailed thing, and I haven't researched it sufficiently for me able to. What I do know is that if retrocausality had been shown, it would be huge news in the scientific community. And I appreciate it does have some problems, but I think other people have said there are problems with this analysis you're offering. Well, there is.
I think that.
No, how do you? There's problems with it, but you don't know.
Well, I'm not familiar with them.
But John, I think, and Rumpus, I think this, whilst it's very interesting, I think it's going vastly over the majority of the audience's head by a country mile. It's very, very deep.
Okay, let's get into gravity then. We'll move on. I just wanted to make a point.
Let's discuss gravity. That's something that I think most people are familiar with gravity, because we're all walking around. So, okay, I'll give you, what, do you want 2 minutes, 3 minutes, 4 minutes, John?
2 minutes should be fine.
Go ahead. You start now.
All right. So they say the gravity is the answer. That's all I hear is gravity this and gravity that. Well, they have to identify which one they're talking about, because you got two types of gravity: Einsteinian gravity or Newtonian. Newtonian gravity is a force. On the other hand, Einsteinian gravity is not a force. So my first question to him is: gravity a scientific theory or is it a scientific law?
Well, gravity.
Hang on, Rumpus. John, are you done?
Yeah.
Okay.
For right now.
Okay, we'll stop that. Rumpus, 2 minutes. Go.
Right. Definitely, gravity, as we perceive it in the real world, is definitely a force. But what actually causes gravity as a force to exist is not actually through. It's obviously to do with the bending of space-time from Einstein's general theory of relativity. So it manifests itself as a force in our reality, but it actually is not derived. It is not sourced from being a force. It is a manifestation in our reality. So it is a problematic thing. So he's right to identify that it is slightly problematic in terms of how to think about it, but this is an understood model, and I can't give you an exact explanation of how that works, but the bending of space makes things basically try and travel in straight lines, but the bending of space by mass causes these straight lines to be bent into non-straight lines, and so they then move, or they don't follow straight lines of movement. They actually get bent by, because when things when you drop an apple, it is actually being attracted to the center of the earth, and effectively its path's being bent by inertia and Newton's first law that things won't move unless they're given a force, or they won't change if they're already in movement. They won't change that. They are being effectively bent by the mass of the earth, and that manifests itself as a physical force in our world. Because of course we can't see space-time. It's not something we can actually see or interact with directly. We can only do it through the real world, and so it's this rule, this mathematical construction of the general Einsteinian space-time thing. I mean, that manifests itself in the physical world as a force. So I think they are compatible, and I think I'd like to be able to give you a really good explanation, but that's I think that's as good as I can give, and I think that's probably as good an explanation. You're asking me to explain quite a complicated thing here.
Actually, 2 minutes, thank you.
Okay.
It's not that complicated. I asked you what is gravity.
Johnny, you want another 2 minutes? Or
yes.
Okay, go.
I asked him, well, not 2 minutes. I'm not going to need that. I asked him a simple question. Because
it's simple to construct, it's difficult to answer.
This is a simple question. Which one is it? It can't be both. One is a force and one's not a force, sir. Which one is it?
Well,
Einstein or Newtonian?
Well, as I said, we've got this concept of space-time that was invented by Einstein.
I just want a yes, just scientific theory or a scientific law on which one. I don't need a story.
Well, gravity is a law. But Einstein, but the general theory of relativity is a theory.
You can't have. So which one is it?
Well, one causes the other. The bending of space causes gravity to exist and have a force. So it's like a sort of second. There's two stages removed here. One stage removed.
Okay. From Musser George, How Einstein Revealed the Universe's Strange Non-Locality, just in November 2015. Einstein created his general theory of relativity, which provides our modern understanding of gravity, with the express purpose of expunging non-locality, we're going to get to that, from physics. Isaac Newton's gravity acted at a distance, as if by magic, and general relativity snapped the 1 and 2 by showing the curvature of space-time and not an invisible force, i.e. Newtonian gravity, gives rise to gravitational attraction. Now, which one is it?
Well, I would agree with that statement. That's that quote you've just given. That it was.
Okay.
He did. I mean, Newton believed he didn't understand the mechanism for gravity. He just went for the action at a distance. You know, there's no medium. Whereas obviously the general theory of relativity talks about the bending of space-time, and then that was the cause of gravity. And so he says, he was trying to break Einstein's action at a distance, and then of course Einstein was then shown to be wrong, because you've accepted what you said with your quantum Deloitte choice experiment you were going on about in the last discussion thing we had, where you seem to be happy with non-locality, the fact that you have action at a distance, entangled photons which interact with one another.
This isn't the same non-locality, sir.
No, but he's trying to break the non-locality. Yes, I mean he's trying.
No, it's not the same non-locality.
Yeah, it's not the same. But Isaac Newton was saying that there's an action at a distance, spook action at a distance.
No, he didn't say that.
No, Isaac Newton did. He was assumed
that about quantum mechanics.
No, Isaac Newton assumed it was instant, and what they're saying here is that Einstein then he determined that in fact gravity propagated at the speed of light. Newton assumed it was instant, and because Einstein then said it was ripples in the space time, and so he removed the what do we call it here, the non-locality. No, he made it local. He made it have a medium. So I would agree.
This has nothing to do with non-locality and quantum. Newton has nothing to do with non-locality and quantum mechanics.
He was, because he was assuming there's
he didn't.
Well,
quantum mechanics wasn't.
Let me finish my sentence. Isaac Newton assumed there was an instant action at a distance, which is very similar to the quantum mechanical non-locality.
It has nothing to do with it, sir. Well, Newton had no idea about quantum mechanics and what.
No, I'm not suggesting he did, but I'm saying they both have in them at a fundamental level non-locality.
Yeah, non-local. So Einstein has. Let's go back to the original question. Just one. Pick one. Well, Newton's law or Einstein's theory. You can't have both.
Well, the gravity that we see in the physical world is indeed a force, but how it's derived is derived one stage removed by the general theory of relativity, which is all about the bending of space-time, and there's a medium and there's a propagation speed.
These are married bachelors, sir. Do you understand the law of non-contradiction?
I certainly do.
Okay, you know the two things that are contradictory can't exist or be responsible for the same thing at the same time.
Well, I mean, whether something's a law or a theory is something that people decide in committee rooms because it's out of consensus. I mean, we've stopped calling things laws these days and such. No one invents laws
anymore. You don't know what a scientific law is. That's the problem. What is a scientific law?
It's a collection of observations that have been verified about physical observations.
It's a description
of
our reality. It's usually mathematical. A scientific
you're right.
Explanation of the cause and effect. They're two different. They're opposites.
Well, certainly things like Newton's. I mean, the thing is, there's been an argument about whether or not you can use the word law to describe things like Newton's law of motion, because that is there's a mathematical representation. Normally, a law is described as a set of observations, and I'm not sure that includes why it happened. I suppose you could argue that it could include the maths for what the observations that we make that we make and observe, and how and so you can say that, for instance, when one thing falls to the ground, we observe that it always takes s is equal to ut plus a half t squared to get from one state to another. So I
they're
think
just descriptions. They're only math can only describe. It can't explain anything. Scientific theories give explanation of cause and effect. You can't do a cause and effect with a law. It's like the second law of thermodynamics. Heat always flows from hot to cold, right? How or why is that possible? Well, We'll never know because
Oh, we do. We know
it's a
exactly why that
nonsensical
happens.
question.
We know exactly why that happens.
No. The mechanism as to how and the why.
Yes, we know exactly every part
No,
of
it's
that.
a scientific law, sir. What's the cause of that?
Right, the cause of that is the most common state is the one that's adopted by a system. So, for instance, if you imagine a set of coins all set to heads, tails up or something. Let's say you had 10 coins, all tails up, and then you decided to, in a box, and then you decide to jiggle that box. What do you think the chances are of them all, at any stage in the future, coming down all tails? It's really tiny because because what the entropy means is the system will adopt the most common, the state with the most number of states, and that is when you've nearly got a 50-50 distribution. Even the chances of it ever going back is almost length of the universe type time before you'll ever get your coins back in even possibly 10 you might have a chance, but it doesn't take very many before it becomes the age of the universe for them, and that's simply due to the probabilities. There are many more combinations of 50-50 coins than there are with all on one side, because there's only one set of coins. Each coin would have to be in one particular state.
Sir, what is
tails
the
up, and well, the cause is probability.
The
the cause is the number of different states. It's simple. It's simple like predicting dice. It's no more complicated.
Just tell me
than
what
that.
the cause is.
Well, I've explained the cause is probability. The number of states.
No, probability
just like
doesn't cause anything. It's not. It doesn't have.
Probability
doesn't cause
it's
anything.
no different to working out the probability of getting rolling a particular number on a dice thing. It's no different to that at all.
That's not a cause. Probability is not a cause. It has no.
Well, I can. Well, I can tell you what the probability of your dice throwing would be, and I can say that it's the probability of 1 in 6.
Cause of it.
Well, okay, the cause is the shape of the dice. But when we understand, once you've got the laws of physics in place, then you can say that we understand, things like molecules bouncing around in a gas or coins tossing. Certainly with the coins tossing one, you can very clearly identify that they can be in one or two states, and if the cause is you can jiggle them around, if you like, you can predict what the behavior of that system will be as a matter of probability.
Okay, here we go. A scientific law versus scientific theory. You didn't answer my question, by the way.
I did talk about law.
Look above at the definitions under law and theory. These definitions clearly differentiate the two words. A law describes what nature does. It's
by observations. I said observations, but it describes
a theory
good enough.
Explains the how and the why nature works.
Absolutely.
Like I just said.
No one would dispute this.
So give me the cause of heat flowing from hot to cold. I asked you that. You went off on dice.
I told you about the probability state is that the probability of a state with the two objects having the same temperature is more likely than the probability of not, and that is the cause.
Probability is the cause, right? So you're saying probability causes heat to flow from hot to cold.
Well, the actual mechanism is through the oscillation of the atoms, but the probability is the thing that determines what the result will be, and that it also explains why you will end up with the two things at the same temperature and mixing well rather than not mixing. It's just a matter of dice throwing. You can do it with. It's no different to calculating the chance of having a dice throw. It's a bit more complicated, obviously, but you can do it just with simple probability. Entropy is all about the system going into the most.
Right, guys, I'm going to have to stop you. I'm getting some shit now off FAD. We've got to move on to the shape of the Earth. End of story.
End of story.
We're not going to discuss philosophical arguments about physics.
They aren't philosophical arguments.
Well, okay. We've got to move on to the shape of the Earth. I need you to bring a point across, John, now, which which is going to prove your hypothesis that the Earth is a flat plane, and then we're going to give Rumpus a chance to rebut that.
Okay, and now you're going to understand the reason why I just went over all that on hypotheses. And theory.
Fair enough. Okay,
now you're going to understand it because I'm going to tell you. Let me shut my screen because I'm screen sharing, right?
You are screen sharing.
Let me turn it off.
Okay. Do you want 2 minutes, 3 minutes, 4 minutes? How long do you want? For your first point.
30 seconds.
30 seconds. Right. Well, I'm going to give you a maximum of 2 minutes, and if you want to say when you finish, then you say so.
Yes, because either a spinning ball spherical Earth or a flat Earth is outside the scientific method by definition. I just explained it to you. You need a viable independent variable for your hypothesis. There is none. There is no cause and effect. And I'm going to show you this here in a few minutes. So I want you to provide me scientific evidence. By what I'm saying is, I want you to follow the scientific method, observe a phenomenon, construct a hypothesis, and then test. Give me an experiment that validates the spinning ball Earth. Go.
Okay. I would set up a focal pendulum somewhere on a reasonable latitude.
We already went over the focal.
Sorry?
We already went over the focal. There's no
and I'm about to.
Pick another one.
So I'm good. So with a focal pendulum, I'll set it up somewhere, and with the physics that we know, basic rotational mechanics, I can say what I expect that pendulum to do if we're on a spinning Earth. And what do I do if we do that? You set up the focal pendulum, and you see that it does in fact agree with the prediction made for spinning. On a flat Earth, it wouldn't happen. The null hypothesis that the procedure that John said would be keen on would be that it doesn't change its angle of inclination with respect to the Earth as time goes on. The spinning Earth says that it will. It changes its inclination, therefore, on a spinning Earth. Similarly, the Doppler effect, we can actually measure that. We know, for instance, that due to the spinning Earth at the equator, it's going 1,000 miles an hour. That has some consequences. For instance, the centripetal force that's required there means that you weigh slightly 0.3% less than you do at the poles. You can measure that. Similarly, with the Doppler effect, given the fact that you're going 1,000 miles an hour on the equator one way and then the other, you can actually see the Doppler effect affecting your observations. Things like the cosmic wave microwave background radiation when you make observations about that on Earth. Similarly, you can see Doppler. Similarly, you can see Doppler effects on that. Obviously, we also have pictures of the Earth from NASA. We can actually see the damn thing. We also see things like stellar aberrations due to the orbit of the Earth around. I don't know if he's also disputing the orbit of the Earth. You can also see things like something called stellar aberration, which you can see the stars moving up and down depending on our speed of our orbit. When we're going towards a star and a certain speed, it's a one inclination, and when we come around 6 months later, when we observe the same star due to Doppler effects, it's lower in the sky. Let's have another one. Yeah, well, that's four complete invalidations, and obviously we've got satellites and pictures and things.
Okay, John, would you like to rebut any or all of those claims?
Yes, he didn't answer my question, sir. I asked him, using the scientific method, to go ahead and observe a phenomenon, construct a hypothesis, and then test it. Well, he didn't do any of it. He talked about the cosmic microwave background fairy tale.
Well, I did. I mean, I summarized it, but I didn't want to go through. I mean, if you want me to go through stage by stage, which is the hypothesis,
that's scientific evidence, sir.
Yes, but I don't need to go through the whole process.
Okay,
I mean,
listen.
This is the problem. This is the problem. You can't take on board information and arguments in a concise manner. And so when I talk about things like it's implicit. It's implicit in my statement that you have a theory about how much Doppler effect you're going to be for the rotation. Then you're going to see, and then see what constitutes a Doppler shift.
John, okay, you're stating that any of the scientific observations and experiments that Rumps has mentioned don't fit with the scientific method. Okay, let's turn it around. I want you to give us an example. What is a valid experiment for anything?
Okay.
Go ahead.
Can I share my screen, please?
I believe you are still. Are you not still sharing?
No, I turned it off.
Well, you are presenting as far as I'm. So if you actually go to your own thing and share yourself, you will be sharing.
Okay.
Because you are still on there. Yeah. Okay.
Okay. Here's something I would just for an example, and I'll get to the actual experiment, but just conceptually. Let's say back in the day, those sailors used to take those long journeys, right? And used to come back with scurvy. So my example here is observe a phenomenon. So sailors appear crippled, they have bleeding gums, and have poor wound healing after long sea journeys, right? The plausible explanations for this, and these are just a few: prolonged exposure to seawater. Possible.
I thought we were talking about the flat Earth here.
Yeah, we're going to get there. This is conceptual. He just asked me a question.
Let him carry on.
He just asked me a question, sir. I'm telling him. So it could be a number of possible problems: inhalation of aerosol sea coal droppings, prolonged exposure to swabbing the deck cleaning solutions, prolonged rolling and pitching, poor air quality caused by smoke and candles, mold, mildew. We just don't know. What about what we don't know? So we're looking for the cause of the effect, the cause of scurvy. So what do? Those are just a few plausible explanations. Do we poll a bevy of current scientists and roll with what most think it is, then call it science?
This is deflection.
Or do we test every possible cause, red, independent variable, and validate the effect, the dependent variable, prediction, science? So let's try to find one. I got one right here, what you asked, for an actual step-by-step.
While you're doing that, can I just mention things
I'm here.
That the sun doesn't change size, which it would on a flat Earth.
Right here.
And on a spinning Earth, it didn't. It's far away.
Hang on, Rumpus, hang on, let him finish. Then you bring that up.
This is all irrelevant.
So back to, it's conceptually relevant, sir. He asked me for an example of an actual experiment or going through the scientific method.
I mean, you've had more than 2 minutes of this as well.
I'm sorry. Yeah, he asked me. What do you want me to do?
Keep it to 2 minutes.
We'll give you plenty.
I already gave you most of my time here.
I asked him to give us an example, Rumpus.
Yeah. And I bet you regret that now.
Valid. Well, that's tough shit, isn't it? Let him finish the point now, for the sake of it.
So construct a hypothesis back with our vitamin C issue. Here is a testable hypothesis. If vitamin C intake is crucial to collagen integrity in humans, then eliminating vitamin C in humans will cause scurvy. This is a valid scientific hypothesis and a testable statement. What are you manipulating, i.e. the independent variable in this experiment? Answer, vitamin C intake.
Surely, moderator, there's a limit on how long you can go on before I'm allowed to have another go.
What are you measuring or predicting? The dependent variable. Answer, scurvy. Do you see the independent and dependent variable connection here?
Yeah. And my independent variable, the spinning of the Earth, was to say here, well, I can't actually change the rate that the Earth is spinning, but I could certainly make predictions about how much Doppler effect there's going to be, what the focal pendulum be, and I can change the latitude of that and see that the deflection of the pendulum is dependent on that. I can also say that the sun doesn't change in size, which you would have to on a flat Earth model.
No, but you can't manipulate that.
We can also see the sun drops over the horizon,
but you can't manipulate that. That's a just so.
Yes, that's why the old definition of an experiment or gaining scientific knowledge.
There it is, right here for you. Look at these.
Bollocks. These are experiments. You can conduct experiments.
One at a time. One at a time, guys.
Jesus Christ.
Look how many. Look how much this is say on independent variables. You have to know this to pass 5th grade general science, sir.
Yes, the trouble is you've found this little issue and you're focusing on it because you don't have the understand.
It's a hypothesis.
The bigger understanding of the issues and how to conduct an argument.
Can you have science without a scientific hypothesis, sir?
No, you need a scientific hypothesis. You need that bit.
You need a hypothesis. Part of that scientific hypothesis is the independent and dependent variable.
And sometimes you don't. So you can still
you just contradicted yourself.
No, you can still learn about the world around you without having an independent variable.
You can't test
the rotation of the Earth. But I mean, even with a focal pendulum, you have got an independent variable because you can change the latitude. If you really insist on having an independent variable, you can change the latitude.
Okay, let's see if it makes sense. The latitude is the cause. Your prediction is what?
No, the cause is the rotation of the Earth.
No, you just said the latitude was. The cause is your independent variable. I said
that's independent variable. Listen to what I'm saying.
That's the cause.
The cause is the rotation of the Earth.
Listen, an independent variable is the presumed cause. How difficult is this?
Well, okay,
and the dependent variable is the presumed effect. This is real easy.
Well, you've got a definition here.
So what is it? The latitude. First, you said the latitude. Right. Second, you said the focal pendulum.
The independent variable is the latitude. The spinning of the Earth is the cause.
What? The latitude causes what?
The latitude changes the effect of the spinning of the Earth on your pendulum.
The latitude changes the spinning of the Earth. That is preposterous. It's absurd.
No. It changes the effect of the spinning of the Earth, I think.
It's preposterous. It's not a cause and effect.
It is. Because
no, it's not. The latitude doesn't cause anything.
The latitude is your variable.
It's not a variable. It's not a cause.
What do you mean it's not a variable? I can change the position of my pendulum with its latitude.
Oh my goodness!
And that is the independent variable that I've got.
Okay, Right. Again, this independent variable thing is just...
I know he's obsessed with it. He's learned about it.
On and on.
He can't get off it.
We're just going to argue about it forever. What we need you to do, what I've been asked by Flat Earth Debates, John, we need you, okay, to provide concrete evidence that the Earth
I just
is flat.
told you, sir.
No. What you've done is you've tried to say that the evidence for a globe Earth is flawed.
That's correct.
What you haven't done is provide evidence for a flat Earth.
Okay, sir.
You've said that the experiments that try to demonstrate. Let me finish. You've tried to demonstrate that the experiments that show the Earth being a globe are invalid. What we need you to do is give us evidence that the Earth is flat.
An argument would do. Argument or evidence.
Sir, didn't I preface this by saying that either the flat Earth or the spinning ball Earth, in conjunction with the scientific method, is married bachelors? Didn't I just say that when I prefaced my discussion?
So married bachelors is your argument for a flat Earth.
Okay, and another thing, let me finish this up. This is my last point. He said that before I can't invalidate. Wait a second, stop laughing. I can't. His point was that I have to propose a replacement. Is that correct?
Well, yeah, give an alternative viewpoint.
It's not. He can just invalidate the globe. I accept he doesn't have that burden necessarily. But he has to justify why the globe Earth doesn't work, and he hasn't done that at all.
Okay.
My
last point answering his question. Your appeal here, sir, the one that's just asked me that question, is tantamount to a judge refusing to allow a defendant to present a case for his innocence until such time as the defendant has found a suitable replacement for the crime. I can still invalidate your model without providing another model.
I would accept that. Yes, it's a reasonable request, but he's right to say that he doesn't have to do this. Obviously, we think he should do, but he can try and invalidate my position, and that's all he can try and do.
Okay.
It's a bit shallow to not.
I invalidated it because it's not validated to begin with. That's the whole problem.
What I'm trying to get at, John.
You haven't provided any contradiction in any way of the logic of the evidence I provided is wrong.
You didn't provide any scientific evidence. You don't have any.
Okay. Now, John, I think Rumpus.
Just ignore the focal pendulum. It's incredible.
Yeah, okay.
No, I don't ignore it. It's not a viable hypothesis. I just showed you.
Okay.
John, go ahead and moan.
It's reasonable to assume. Okay, what you've so far said is that you don't believe the Earth is a ball.
What I so far said was that you cannot place either a flat Earth or a spinning ball Earth into the scientific method. It's nonsensical, and it's a non sequitur fallacy.
Okay, so you're saying you can't possibly prove that the Earth is flat either?
You can't, not with the scientific method, you can't.
Okay, so do you believe the Earth is flat?
I believe this is not about a believe form. This is about scientific evidence form.
I just asked a question. It's a yes or no answer. Do you believe the Earth is flat? Yes,
it's irrelevant.
No, it's not irrelevant. It's a question.
Yeah, it is. To me, it is.
No, I'm asking you a question from one human being to another. Do you believe the Earth is flat? Yes or no?
I told you. This is a scientific discussion.
No, if I said to you, do you like honey? You could say yes or no. Do you believe the Earth is flat? Yes,
Did you understand my position on scientific evidence?
I didn't ask if you believed the Earth was a globe. I asked if you believed the Earth was flat. You could say yes, no, or I don't know.
You keep on saying believe, though. You understand my position with the scientific evidence.
Yeah, but in your belief system, in your mind, do you believe the Earth is flat?
I take what the Bible says it is.
And what do you interpret the Bible says?
It says it's flat and non-spinning and domed.
Okay, so the answer to my question is yes, you believe the Earth is flat.
My belief, but that wasn't the subject of the debate.
That's your belief. Okay. Can you, based on the fact that you've got a belief, something must have led you to that belief. So can you provide evidence?
Yeah, for the Bible, that would be a long.
No, we're talking about science. We're talking about verifiable empirical. We're talking about empirical evidence. You're very keen on empirical evidence, John. We want empirical evidence.
You just asked me what my beliefs were, sir.
Yes, okay. Now we're asking for your basis for your beliefs.
I just told you.
It's
The
because
Bible, God.
Right, so you don't
the
have any
Creator.
empirical or scientific basis for your
So
beliefs.
Oh, yes, I do. For God,
Right,
I
let's
do.
hear
Yes.
them. Let's hear them then, please.
Sure, no problem.
Jesus
Okay,
Christ.
go ahead.
Okay, here we go.
Oh.
Okay.
Scientific law. This is mine. I made this up. I constructed it.
So this is your belief.
What's so funny about it?
Well,
No,
we thought we were talking about flat Earth, but now you're doing
Rumpus,
it for God, are you?
Rumpus, let him
You
give
just
his
asked me to do it.
Rumpus, let him give his explanation. You're gonna.
He has been talking for the last 10 minutes when I've barely been talking at all.
Okay, yeah. What we're trying to get to is some.
No, it's okay,
Paper.
Paper. Go ahead, Paper.
We're trying to get some proof that some evidence that the Earth is flat.
No, I'm giving you. I said my belief is from the Bible. You asked me.
We want to know whether
God.
you have any empirical evidence to support them, or any scientific evidence, or
I
arguments.
just told you from the beginning that the flat Earth or the spinning ball Earth is outside scientific methods purview. I just told you that how many times?
You did mention that once before. I wanted to make sure that's what your position is.
That's my position.
Guys, I think a point that needs to be made here is that we're starting to invoke religion and the Bible here.
No, this isn't religion. Christianity is not a religion, sir.
Well, you're taking your beliefs from your belief in the Bible is.
Well, Christianity. The tenet, the quintessential tenet of religion is belief without evidence. My position is that your materialism religion, which I just beat over the head during this discussion with quantum mechanics, is a religion. It's you who are religious, not me.
I see.
We base our positions on argument and evidence, and you haven't provided any argument or evidence for your positions.
Not evidence.
Empirical evidence. Yes, and I've offered you an empirical evidence. I can show you a focal pendulum. I can show you a focal pendulum.
We already did the focal pendulum.
Yes, and we've established, and it is empirical evidence. Just because you didn't understand,
I just showed you.
No.
Yeah.
I don't understand how you could not understand this.
Because you can't formulate a scientific hypothesis, sir.
We can. The hypothesis is that the pendulum would behave in a particular way. That's the hypothesis.
Okay.
And when it behaves in a particular way, hold on. You've spent the last 10 minutes talking. How about me having a go? I can show you a focal pendulum, and I can say that the spinning Earth predicts it will behave one way, and a flat Earth predicts it will behave another way. And it goes with the spinning Earth thing. Similarly, we can show the Doppler effect, which is occurs with a spinning Earth. I can also show you star movement that occurs with a spinning Earth. And none of those things would happen on a flat Earth. Therefore, because we have evidence that those things happen, the postulation that there's a null hypothesis saying this won't happen, and then there's a hypothesis saying, well, we do expect to see this phenomenon. In each case, we see the phenomenon that is compatible with the spinning Earth and is incompatible with the flat Earth. And similarly, those pictures I can show you of Chicago, those are not possible to happen on a flat Earth. They're only compatible with a spherical Earth. So therefore, it's case closed. You have no evidence. You have no argument on your side whatsoever. And all the evidence and argument is on my side. It's case closed.
Okay, 1 second, sir. Can I respond?
Yeah, go ahead.
I've already showed that he can't formulate an actual scientific hypothesis to empirically validate any of his claims whatsoever. I've already showed that. He keeps on talking about predictions, right? A prediction. What's the difference between a Nostradamus prediction and a scientific prediction?
Okay, John, can you provide something, for instance, an experiment which follows the scientific method that proves that the Earth is flat?
Well, he said
I already told you.
You can't do that. He said you can't do that.
I already told you. I premised my last point by saying either a flat Earth or a spinning ball, spherical Earth, is outside the purview of the scientific method.
Okay,
he's a nutter. In other words, he's saying he's a nutter.
Do you agree it's one or the other, though? Do you agree it's either a spinning ball or it is a flat motion?
Yes, I do. Yes.
It's one or the other.
Yes, I do agree with that.
Do you accept that there's many more experiments that have been done that show the spinning ball Earth rather than the flat Earth?
No, I'm saying, sir, that you can't see, the hypothesis is your experiment statement. If you can't form a viable scientific hypothesis, you don't have a viable experiment.
Okay, at what point do you think there will be a viable scientific hypothesis?
There won't be.
Of the flat Earth? There won't be. It purely comes down to belief in the Bible.
They're
No,
what mine does.
John, the paper. Sorry, he's conceptually decided that there's no way you can do an experiment. To
No, it's not
whether,
conceptually; it's empirically.
Okay, empirically you can't do it. Whatever.
So,
he believes it's impossible to prove one way or the other.
He brought up another point about his.
I mean, this is incredible.
Skyline.
I mean, even the flat earthers are calling John. Even the flat earthers are calling you a nutter. I mean, this is getting ridiculous.
I don't care what they call me. I don't care about what people think, sir. I deal with empirical.
Well, we gather that you're a nutter.
Empirical evidence, sir. And you brought up refraction. Can you list the effects of refraction for us, sir, with that skyline? List all the effects of atmospheric refraction from the ground. Go ahead. You can use Wiki. I know you're on.
Okay. Well, I've actually got a little video here. Actually, it shows you the effects.
No, I don't need a video. Just
I can show you.
List
by
the
observation.
Effects. List the effects.
Well, I can show you the effects.
John, a video is perfectly valid. I mean, you're showing text on the screen and things that you've taken quotes from other people. Rumpus wants to show a video.
I'll show you.
Asked him
Why is that invalid? Why is that invalid?
Effects. It'll take 15 seconds.
No. Well, I can show you. I can show you the effects. You're asking me to show you the effects of refraction, and I can do that. That's what you asked me, and I can demonstrate it on that. And you even on that picture, you asked me specifically refraction effects on that picture. And if I can just go here, I won't play the video. I won't play the
atmospheric refraction effects.
I'm just going to show you the refraction effects. I'm actually going to show you them.
Why should you? You could just tell me.
Oh, I can do better to show you. It's even more solid. And rather than you complain that when I say things, it's just opinion.
I'm not going to complain.
This isn't just opinion.
John, you are familiar with visual aids, surely?
Yeah, I am familiar with visual aids. I didn't ask him for that.
Yeah, but Rumpus is going to give that for the benefit of the audience as well.
Right. Here is a video taken by Joshua Nowicki of the Chicago skyline from Stevensville, 90 kilometers away. And here, this is taken from about over 200 feet high. So he's on the tallest dune in Stevensville, and he took this as a time lapse picture of Chicago over the period of a day, I think. And you can see. I'm not going to play it because I know that Fed doesn't like me playing, so I'll just take bits of it. So this is the first. And what I would suggest you do at home, people, is to try. Can you see my pointer? Can you see my pointer? Paper.
Yeah, I can.
Right, there's the top of there's the Willis Tower. I suggest you put a window or something on your screen or your finger or something like that on that point there, just to that step of the Willis Tower. And so here we go. I'm now going.
Yes, I've seen 3 hours of this the other night.
No, this is a bit different. I'm showing you this. This is going to show you how it changes. Well, can I continue? Right. So if you put a pointer, your finger or something there. And because my pointer will move, I have to move my pointer, but also it'll disappear if I just hold it there. But if you then move along here, you should see. Unfortunately, I'm going to play it a little bit. And if I hold my pointer there, you should see that it's going up there. You should see. Unfortunately, the pointer disappears. If you put a screen, you can see that the antenna is growing and growing, and now it's coming down because the day is getting colder. And it'll now, and you see it's moving up now by about 10%. Oh God, the trouble is and now it's shrinking because the day's getting colder. And you see it go below the pointer. Oh, come on, as the day's getting into the evening. And I suggest you look at that video yourself at your own leisure, and you will see there that is refraction occurring due to the heating of the layers in the sun. Just as the day warms up, you get these layers of less dense air. Because you remember that's 90 kilometers, and you're looking there through quite a small strip of warm air, and that changes obviously in temperature as the day goes on, and you can see the physical effects of that. So there is refraction happening in front of your face and changing the appearance of the Chicago skyline. Thank you.
Okay, I asked a question. I said, please list all the effects of atmospheric refraction near the ground, and you didn't answer the question. So
well, I demonstrated them.
Let me answer it for you.
I've shown you them.
Atmospheric refraction on the ground produces mirages of distant objects. They can shimmer or ripple. They can be elevated or lowered. They can be stretched or shortened. Now, what I want you to validate scientifically for me, please, those are all independent variables.
Oh, Jesus.
Yeah. So can you validate what's happening in that picture for me? Scientifically, please.
Yes, because in the lab, we know that light is refracted. We've done experiments in the lab.
We're not talking about in the lab.
Yeah, but hold on. I can demonstrate the print. Well, you want to conduct an experiment, and we can do things like change the time of day, and that's compatible with what we see in the lab, where we can see that we can get refractions in medium. We can change the temperatures and do this experiment in the lab.
Yeah, but you can't do
hold
that.
On, can I finish? So in the lab, you can demonstrate that a change in density of air causes it to refract, and then we can see here that we're getting exactly the effects which we know are due to heat things. Now, we could put temperature, we could put thermometers and things in there, and there are ways of detecting air temperature that then are compatible with our lab experiments, and therefore we can say it's the same effect.
What's the alternative explanation, John, is what we're trying to get to? What's the alternative? If you've got a valid
there you go again with the alternative.
But, if you're saying that experiment that is invalid and the explanation given is invalid, can you come up with an alternate explanation which is valid?
I just told you about your philosophy with alternate explanations. I gave you the different effects of refraction. I want you to isolate what effect that is happening in that picture for me, please, scientifically. Thanks.
Well, I think Rumpus just said it's refraction of light.
But refraction has different effects. Do you want me to state them over again?
And we saw the different effects. It shrank and did all sorts of things.
It could be elevated or lowered, right?
No, it did that. It did that.
Right? So which one is it?
We did both, depending on the temperature inversion. Whether it was an inverted one, whether... Yes,
so it doesn't say anything. You can't validate what it's doing. You can only observe. Observations are not tests.
Okay. So we've made an observation that what appears is the building getting higher and lower, etc. What is the alternative explanation, John? Is what we're trying to get to.
Your key statement is it appears. Observations are not tests. The independent variable.
Observations are not tests.
Okay, so what is causing that observation?
Oh my God! Yeah, I know the science. We shouldn't let the scientific method get in the way of your friggin' fairy tales.
What John seems to be doing here is saying that everything is invalid. You can't prove anything. No observation
Not everything.
counts.
I said the flat Earth.
Yeah. Versus... No. You've basically said every observation. You said an observation is not a test, whereas I would argue an observation is a test. You can make an experiment, and then you make an observation of what happens.
Okay.
And there's an observation. So your basic whole argument you've been having here is nothing counts.
Here's
no evidence, no argument. It doesn't work. So you haven't presented a case for opposite, which I understand. Like I'm prepared to accept.
You haven't presented anything either.
But all you're saying is everything, all the evidence I presented argument doesn't count because nothing counts ever.
Next to zero, by the way. You don't even know what a hypothesis is.
You've said that no evidence or argument can count for the round or the spherical or the flat. You said
nothing. You can't put it empirically.
Well, I mean, there you are. He's not prepared to accept any experiment, any evidence, or any argument. That's his position. No matter what.
Any argument. It's just argument with these two.
He's not prepared to accept any argument or any evidence. He stated that.
I don't need to accept it. You need to sell the experiment.
There we go.
John, right. I'm going to start muting people shortly. Right, John, what we're saying is those observations were made. Do you agree with that or not?
Yeah, you can look at something, sure.
Effect. Now, what science tries to do is explain those effects. Now,
science doesn't explain.
I'm going to mute you very shortly if you don't let me finish.
John, you are the moderator.
Go ahead. Science says, go ahead.
John, you are the moderator, not actually really supposed to be participating in the debate.
Listen, no, I'm not trying to participate. I'm saying he seems to be avoiding the question.
That's yes, I agree.
Yeah. I'm just trying to point out that Rumpus has said that observations were made, which is valid. We agree that the observations were made. And science has offered an explanation. And you're saying that that's invalid. What we're trying to get at, John, is what is your alternative?
Science can't offer an explanation, sir. It's not an entity. It doesn't have vocal cords. So it's a reification fallacy, for one. Right? Because science is the scientific method. You got to the first step of the scientific method. You made observation of a phenomenon. What's the next step?
Is to try and deduce what that is causing that effect.
Construct a hypothesis. Go.
Correct. Okay. Correct.
Right. So the problem is that John doesn't believe the science can have anything to say on this subject, and I suspect it's because of his religious beliefs.
Science doesn't say anything. So he's trying to exclude
us having a scientific discussion about this issue, which I'm afraid is somewhat well, I would argue it's the fact they're coming into a debate where he's prepared to say, he's saying that basically science can't comment on this, I think is a bit ridiculous.
Science can't comment on anything. It doesn't have vocal cords, sir.
So what you're saying is we should all, whenever we observe a phenomenon, we should not bother trying to explain it. Is that
No,
what
you
you're
should.
trying to say, John?
You should start trying to test it scientifically, please.
And how
That's
would you
what
go
the
about
scientific
testing?
method is.
How would you go about testing the effect of the Willis Tower
Refraction.
growing and lowering in height? How would you go about that?
You can't. That's what my whole point, sir. You can't put it in a
You can't do it.
hypothesis.
You give up
No,
on the
you don't have a viable independent variable that you're
Okay.
manipulating.
So what you're saying is we give up on the subject.
I don't think you can give up. It's just not scientific evidence.
Okay, so can you propose a test that would probably explain why you see that? You know, you're standing at the shore with your 3-year-old child, and he says, "Daddy, why is that doing that?" Do you just say, "Well, there's no way of testing it. There's no way of answering that question"?
That's his
I can give
position,
him-
yes.
I can give them the possibility, sure.
What are the other alternative possibilities than the ones that Rumpus gave?
Well, it's just like my vitamin C example, sir. I gave you about 6 different ones.
Now we're talking about the Willis Tower.
Yeah, I know. It's the same
and-
concept.
Yeah, but you know, Rumpus has said, you know, that scientific experiments have created an idea of why this happens. You're saying that's invalid. What's the next step? We want to come up with an answer. Now you've said that his explanation is invalid. So what's the next step? We need to then come up with a viable alternative.
It's not only invalid, it's not viable at all because you have different effects. I just gave you the different effects.
Okay, so can you come up with something that does explain it?
Like scientifically?
Whatever. Any
No,
explanation.
no, it's not whatever. We're talking
Whatever
about
you like.
scientific evidence, sir.
Yeah. Okay.
And he's laughing because he doesn't know what it is.
No. I'm asking you a question as an independent person. Why is that tower look higher at 3 o'clock in the afternoon than it did at 11 o'clock this morning, Daddy?
Refraction.
Pardon?
Oh,
Refraction.
yes,
So you
correct
get the
answer.
refraction cause.
Wow.
Sure. Refraction,
Okay,
definitely, but you can't. It can be elevated or lowered or
Yes.
stretched or shortened.
As I
Okay.
demonstrated, yes.
Due to different levels of refraction.
Yeah,
So
it doesn't
agree
prove
on,
anything. It could
we
be
agree
anything.
on that.
It could be anything. Yeah, it could be any of those, or all of them.
Okay.
Yeah, but we can eliminate some of them. We could check it on days when there isn't a temperature inversion. Say at night when we know there's a uniform temperature, for instance, we can measure the uniformity of temperature. If our prediction is that there has to
what's
be
your
hold on, let me
independent
finish. Hold on, you speak about bloody hours here. We could say, in the lab, we believe that the density of the air is responsible for refraction. And that is caused by a difference in temperature. So scientific prediction would be that should be a variation in temperature in the atmosphere above the lake. There should be a variation there. We can go and test that and then establish and see if that then matches the lab results, and then say, oh, so that would be our independent variable. We could go out on particular days of particular temperature and then see if we get the effects we do. And then also when it's going at night, we could see that the temperature goes down and then we get less refraction. So we've got a number of things we can play with to establish that if our predictions are then compatible with what we see. And then we have a null hypothesis, and then we have the observations that we can make, and then see if they're compatible with our predictions. In the case of the refraction thing, we say, well, when we expect to see large temperature variations in the atmosphere, we expect to get these refraction effects. That's what we see. We do not get the effect where the temperature variations are uniform and we get the refraction. And therefore, we have a result, and we can establish that the refraction is the cause of that effect.
But you can't superimpose a lab experiment onto the lake and say, okay, you have to know all the variables, sir, to isolate what the problem is.
Yes,
and what the cause is.
Agreed. You do
You
have to
can't
minimize the number of variables, which you can do. You can
predict.
So what you can do is you can.
Wait a second, I'm not done yet.
Yeah,
You can't predict. Your prediction is your dependent variable. What is your independent variable on your tester, sir?
The time of day that I choose to make the observation.
The time of day. So you're manipulating. The cause is the time of day.
No, the core. You found a definition. You found a quote from someone that said that the independent variable is the cause. I dispute that. And because you're stuck in that
I found
quote,
it.
You're stuck in that quote. You
got
can't be
special
shifted.
mind powers. Where'd I find it at?
So the independent variable I can have is the time of day that I choose to make the observation.
Cause.
The
independent variable is your cause.
The cause is the actual physical reality, the temperature.
The cause in an experiment is the independent variable.
No,
your prediction.
When you're natural phenomenon, you can change something, your independent variable. What you so for instance, the voltage on something, but the system then responds.
That's the cause.
No, it's not.
Yeah, independent.
No, the system the system.
That's what our problem is. You don't understand the scientific method.
There are times
or
when
a hypothesis, sir.
You don't seem to understand. There are two sorts of experiments. One in which you can inject something into the system to make the system change, and one where you make observations of the system.
Oh, observation! I got that. Hold on, observational studies, right? I got that. Hold on 1 second.
Right.
I had that for you here. Observational studies, right? There's different types of experiments. So let's go with observational studies. Because that's what you said, correct?
Yes, I did say that. Yes, but I mean the fact
observational studies are not experiments. By definition, observational studies lack the manipulation required for Baconian experiments. Natural experiments are a different type of quasi-experimental design. There is not a variable that is being manipulated by the experimenter. And what does quasi mean?
The change of temperature. I mean, sorry, the change of day. Well, nonetheless, but you're saying you can't draw any scientific conclusions from conducting.
That's right. That's what I'm saying.
And you can.
I'm not really saying it. I'm showing.
And you can.
I'm showing it.
You've obviously read something in your Wikipedia months ago, and you've got fixed on this thing, and you seem to got stuck in this little rut. And logic and argument, evidence is not
my favorite color.
Well, that's
how do you know that?
Because of the way you're talking.
Oh, the way I'm talking.
You're not approaching this in a logical or scientific way.
I'm using the scientific method.
No, yes, you're not arguing in a logical or intelligent way.
This is the scientific method. Is a logical method. I just gave you a hypothesis.
But your conclusion is you can't draw any scientific conclusions.
Yes, I can. You don't have a viable independent
Okay, let's call
variable.
it a quasi-experiment. Just for you, we'll indulge you. We'll call it as a quasi-experiment. I believe that can lead us to conclusions. You're saying it doesn't, and that's wrong.
Yeah, because quasi means not really.
No, it doesn't. It means that, remember, it's a modifier of experiment. The word experiment. Now, if you
there's not a variable. It doesn't have an independent variable. It's not a hypothesis.
I'm going to stop you both. I'm going to stop you both. We're going nowhere. We are in. No matter what you say, it's semantics. It's
not semantics. The scientific method is not semantics.
Basically, John, you're trying to say
we don't need your opinion. We don't need your opinion.
No.
You're a ball earther. We don't need your opinion.
I am here as a moderator, and I have to intervene when you're going.
Of course, but you're biased.
You're going.
You don't know what science is. Okay,
totally
you tell
and
me.
utterly off topic, and everyone agrees. Everyone in the chat agrees.
Consensus then.
Well, yeah, but I mean, when you've got 100 people who disagree with one person,
I don't care what they do. I'm not into consensus.
We know that you don't care, and everyone's wrong. You're right. Okay, that's fine. But we need to talk about that. You need to either accept that scientific experiments are valid. You know that there are scientific experiments conducted in all walks of life, and there have been for thousands and thousands.
Yes, I know that. That's a straw man.
And the scientific experiments prove things. That's how we advance as a species. Okay, you've got to accept that scientific experiments are done.
I do accept that scientific experiments are done.
Yeah. Okay, so let's move on to an example of a scientific experiment that proves that the Earth is a flat plate.
I just told you there isn't one. You can't formulate. Why don't you try it?
Yeah, paper.
Give me a scientific hypothesis.
Yeah, I mean paper. He's adamant that you just simply can't do any science on the Earth.
And you can't because you can't do it.
Yeah,
that's why.
No such thing as a scientific experiment, then, John. You've
misunderstood what you've read. I said there is no such thing as a scientific experiment to validate. Listen closely now. Flat Earth versus a spinning ball. Hard stop.
Yeah. Okay, John, you're going to have to. Your paper. You're going to have to. He said this now about 10 times. You're going to have to accept that's his position. There's nothing. There's no scientific. There's no scientific way of determining to him that the Earth is flat or spherical. There's no observation. No observations.
Well, no, I think his position.
I think John. It's insane. It's a nutter position.
Well, I think.
There we go with the name calling again.
Rumpus,
that's all you got.
Stop. I think John. I think this is a fair point to make. Is that what you said is there is no valid experiment to prove that the Earth is a globe
or flat. That's what I said.
All flat.
Now,
So do you
now to
think,
refute that.
do you think the Earth is flat?
Oh, here we go. Didn't we just go back over this before? You said, what do I believe?
You believe it's flat because you believe the Bible.
The Bible? Yeah, I believe.
Yeah,
Okay.
paper. He's saying he's not prepared to involve science in that debate. He's only going to go via his book. So he's not prepared to say that science can have any opinion. He's eliminating the possibility.
Science doesn't have an opinion. It's not alive.
And I suspect, and half the reason he doesn't want science to have an opinion, because he knows it would invalidate the flat Earth.
So he's trying. So you're reading my mind or something?
Well,
that's an appeal to motive.
Motivation. You don't want
that's
science
an appeal to motive fallacy. That's an appeal to motive fallacy.
It's the only conclusion. No, I mean,
it's
not most flat earthers would not resort to the argument.
It's a fallacy.
It's very desperate.
And then here's another fallacy. Argument to popularity.
You both in 5 seconds. I'm going to tell you something now. We've got an argument here, a debate here, that is based on two entirely separate levels. One is based on religion. One is based on
science. It's not. No, yes. Whose religion?
Your religion.
John. No, it's your religion and his religion. It's called materialism.
Religion. No, you believe in religion of the Bible. You believe in the word.
No, that's not religion. I already told you that.
No, it is a religion.
No, it's not. The basic tenet of a religion is belief without evidence. I can prove there is a creator.
Okay, can you prove the Earth is flat?
I just told you that scientifically I can't.
Yeah, paper. He's made this very clear that science cannot comment on the flatness or sphericalness of the Earth. He said this many times.
This entire debate is totally invalid.
Yes, indeed. He's not prepared to go in empirical argument or evidence
because there is none.
It's irrelevant.
Offer one when there is.
So it doesn't matter what arguments I make, what empirical evidence I offer him.
Yeah, you can show it. I just asked you to show empirical evidence. I want you to observe a phenomenon, construct a hypothesis. You know the scientific method. You know that.
So, and he's not prepared. He doesn't believe it. He thinks it's conceptually impossible to present.
Oh, he's done that already, right?
Scientific.
Well, he's given many examples of measurements
like what? The so-called pendulum. I just destroyed all those. There is no independent variable.
No, you didn't destroy them, John. You gave your opinion, John. You didn't destroy them.
No, I showed you what an independent variable is and its function.
I mean, John, this is incredible.
How many times do I need to
John, on a flat Earth, the focal pendulum will behave one way. On a spherical Earth, it will behave another. That is evidence. I mean, for goodness sake.
Yes, that's the cause. The latitude is the cause of the focal pendulum. Yep, you said that.
I think a better debate would be someone like Rumpus against someone who is
interested in science,
like a pseudoscientist, like he is.
No. Someone who thinks the Earth is flat but isn't driven by religion. I think that would be a more valid.
Your religion. Well, what about your religion, materialism? Do you know that has been falsified?
By definition, science isn't a religion.
Materialism and realism, the basis of your religion, sir, has been falsified by quantum mechanics. It's called non-locality.
So you believe in quantum mechanics?
Quantum mechanics is a science.
Oh yeah, it's okay. So you believe in that?
I don't need to believe in it. It has thousands of experiments to validate it.
You spent the first 3/4 of an hour of this thing going on about quantum mechanics.
That's right.
So you believe in it?
I don't need to believe in it. It's science. Real science. You don't believe in it? It's real science.
Quantum mechanics is real science.
That's correct.
I see.
And why is it? Because of the experiments.
And Newtonian physics and observations and things that can be replicated in the lab is not real science.
Well, Newtonian mechanics was falsified by quantum mechanics, sir.
No, you watched one video and he.
There he goes again.
It's my turn to talk. It's my turn to talk. It's my turn to talk. He showed.
No, it's not your turn.
It is my turn. You've been speaking far more than I have in the last half an hour. Far more. It's my turn to talk.
No, I gave you some of my time, sir.
No, you didn't. No, you've been speaking far more than I have. I've had.
Yeah, we're done with this debate.
Hold up.
We're done with this debate.
So he showed a video.
I believe we are done.
He showed his last point.
I believe we are done with this
debate. Okay, last point. He showed a video the other day.
You don't have a point.
The other day, where this chap said that Newtonian physics was in there, and all he was saying was that it was being superseded by quantum mechanics, but he wasn't disputing the Newtonian mechanics works, because of course the quantum mechanics situation approximates to the Newtonian one at the macro scale.
It doesn't approximate it.
So Newtonian mechanics does work, and this lecturer would not. Hold on, I would like a few seconds to speak. And this professor who was lecturing at the, I can't remember what it's now in a video, he was not going. If I had been able to approach him and I asked him, does Newtonian mechanics work or not? at the macro scale, he would have said yes. And it's been proved. I mean, the mere fact that we send things to Pluto, which rely on Newtonian mechanics, and any number of other things show that Newtonian mechanics works at the macro scale.
Begging the question, fallacy on steroids. So, Newtonian.
You're a nutter. You are A1 bonkers.
Newtonian mechanics. Yeah, call me names, because that's all you got. So.
Just bonkers.
So, Professor Shanker, the professor of physics at Yale. All right. So today we're going to shoot down Newtonian mechanics. We're like the press. We build somebody up only to destroy them. Same professor.
Yes,
First, I want to tell you what goes wrong.
At the
First, I want to tell you what goes wrong with Newtonian mechanics.
At the nanoscale, we know that quantum mechanics.
The double slit experiment is a problem. That's what puts the nail in the coffin for Newtonian physics. And yet, so that means your syllogism is, all that means is that Newtonian mechanics is true, right?
It's a very good approximation.
I think we're done with this discussion because I've already proved my point.
John.
It's not an approximation. No,
it is an approximation. It's a very, 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 very good approximation.
Oh, very, very, very support it.
Yes, at the macroscopic level, it is a very good approximation.
Support it. Support your claim.
The fact that pendulums
you're
work
laughing,
exactly as predicted, and that ballistics work as
you need
predicted.
An independent variable to predict something.
They work as predicted. I mean, that's why when you
so does Nostradamus predict stuff. I can predict the Super Bowl next year. Is that a scientific prediction?
When you fire a shell out of a cannon, John, it doesn't fly off behind.
Oh, here we go again. I dealt with this last time.
It follows a ballistic path, which is predicted by Newtonian mechanics. It works. It works in everyday life.
We've never found a situation where at the macro scale Newtonian mechanics doesn't work. It's been shown again and again to be true.
Okay. The laws of physics are always quantum mechanical laws. You don't have separate laws for big and small things.
Which approximates Newtonian
laws. The real question
is,
is, how do these very same laws, when applied to big things, by big things I mean the things you see in daily life, here's the kicker, give the impression the world is Newtonian.
Because the mathematical equations reduce to the Newtonian physics.
Mathematics is not physics, sir.
The mathematics behind quantum mechanics reduces to the Newtonian approximations at the macro scale. It's very simple.
Mathematics is not physics, John. You just destroyed your opinion. I think we're done here, sirs.
This guy's a nutter on steroids, isn't he? He's absolutely
That's all he can do is call me names,
John,
because that's all he's got
things
left.
On the macroscopic scale, John, in everyday life, the big things that we take can be explained perfectly with quantum mechanics. It's just that the mathematics and the things that the calculators involved by using quantum mechanics would take a universe lifetime in order to calculate.
Mathematics does not explain anything. It merely describes.
No, yes, but it makes predictions, doesn't it?
No, it doesn't predict anything. It doesn't have any.
You do, because you can plug in numbers. I can plug in numbers into the quantum mechanical equation, and then that gives me the results at the Newtonian scale.
Nothing in quantum mechanics mathematically is derived, Professor Shanker.
Right. Okay.
It's bonkers. Absolutely bonkers.
Because I know all your arguments. I know all of them.
You're just a nutter.
I know them 6 steps in advance before.
Right, I've muted you both because I need to just say something. Fed, I think this debate has